Hello Finsters, welcome back. Llama 2 is everywhere, so why will we be keeping us away from the landscape of Llama 2? I'm very much eager to know about the new things. In here we'll be starting knowing about the Llama 2. Llama 2 is crossing the chat GPT in every aspect, so how is it crossing? We should know this thing. For that, let's check something here. What are the models that the Llama 2 has come up with? So you can see there are three model size here. This is with the parameters, that is 7 billion parameters, 13 billion parameters, and 70 billion parameters. And here it is written that Llama 2 was trained on 14% more data than Llama 1 and has doubled the context length. There are so many benefits and it is competing with ChatGPT, and most of the people are saying that it has already crossed ChatGPT in many aspects. So let's check it out practically. So there are so many procedures of downloading these models and using it on your own browser or PC, but let's jump onto an easy solution and check how it works for you. For that purpose, we'll be using this Together AI. This is the cloud service for developers to build with open source AI. So you just click on get started and you'll automatically ask for login. As I have already logged in, that's why it is not showing anything, but you just sign up and open an account. Whenever you will sign up to this Together AI, you will get 25,000 free credits as for a free trial, and I think this is more than enough to check on the Llama 2. The main benefit of using this Together AI is that it is hassle-free and you can use the playground here without any cost, because you will be getting 25,000 credits, free credits, and I think it is more than enough to run on. So just move to the playground here. For that you need to move to this Together AI. If you get inside this model section, then you will see that these are the three models available here. That is Llama 2, 13 billion parameters, 7 billion parameters, and 70 billion parameters. So we'll be trying with all of those. So let's get inside this Llama 2 Chat 7B model. Just click on this and you'll see it will be opened. Just click on open. So this is the playground, Llama 2 7B playground. Now here, ask the model a question, that is the question that we asked to the ChatGPT in our first prompt engineering course, that is how many vowels are there in tropical. If you can remember, we have asked these sorts of question to the ChatGPT whenever it first came. So now we are asking the same thing to the Llama 2. So let's see how it answers. So here it is saying that the word tropical contains 3 vowels, so it is a clear mistake. You can see he's showing that O, and A. So it's a clear mistake because there is only one O in tropical, but here it is showing 2 O's here. So that's a clear mistake. So how can it be more powerful than ChatGPT? Don't be confused, it is powerful, but you need to fine-tune this thing to get the best output. Now we have checked this Llama 2 7B model. It failed to answer this question. Then let's go to another model. That is, now I will be using 13 billion parameters model. So let's check it out. Yes, here you can see this Llama 2 Chat 13B. We are asking the same question, that is how many vowels are there in tropical. Here it is again failing. That word tropical contains 4 vowels, O, E, and A. Even the 13 billion parameter model fails to answer the question, that is the word tropical contains 4 vowels. Again, it is absolutely wrong. Now we'll be using our last model, that is 70B. So let's move to the models again. 70B, this chatbot. So let's open this and here enter the same text here. Best tropical. So you can see here even the most powerful model, that is the Llama 2 Chat 70 billion parameter, is also failed to answer the question. Here you can see there are 4 vowels in the word tropical. So how? So why every time is it coming up with the wrong answers? Because the model needs to be fine-tuned before using. So for that, if you go to the modifications here, you can see these default models here, system prompt. So you can see the system prompt. This we'll be learning about the system prompt option in Llama 2. This is a new concept, and now they are using the default system prompt, but we want to change this thing. This system prompt can act as a customer support agent, it can act as an email writer, or it can act as an open chat kit. So we have the option to change the system prompt from here. So we are changing the system prompt. So we are just going for, let's say we are giving the prompt a name that is self-assistant. So it will act as a self-assistant now. Assistant, and our system prompt will be a simple thing that is you are a helpful assistant. We are not going for the default prompt. We are using this system prompt here. So now save this thing, and from here we can use this self-assistant system prompt. And now we need to train the model. Now if we ask the same question to the model, that how many vowels are there in tropical, then let's see what comes as answer. Okay, I think this is failing again. So I need to teach the model how he should think about solving the problem. You may remember whenever the ChatGPT first came, we used to solve this sorts of problem by using the think step-by-step method. So here we'll be also using the same thing, same concept here. So you can see how many vowels are there in tropical. So work step by step, letter by letter. For example, for bed, I want you to write B is the consonant, E is the vowel, and D is the consonant again. So the total vowels in this word would be 1. So think in this way. Now let's check if the model can think in this way. So here now you can see the here's the step-by-step breakdown of the word tropical with the number of vowels, that is consonant, consonant, vowel, consonant, and then you can see OIA is the vowel. So total vowels is OIA. So I hope this helps. Let me know if you have any other questions. So you can see from here that now we have got the correct answer. Now I think you are not confused as to Llama 2 is why Llama 2 is unable to answer this sort of question, because you need to train the model in the perfect way. It solves this sort of question. So now if I ask him another question, that is, so now I'm asking a difficult question, that is how many vowels are there in each days of a week. Now will he be able to answer the question? Let's see. So now you can see here, now he's coming up with difficult answers, that how many vowels are there in each days of the week. Sunday 3 vowels, Monday 3 vowels, Tuesday 3 vowels. It is considering the Y as the vowel, and here it is considering R as the vowel. So it is doing some mistakes again. So what should be the perfect prompt for this? Let's redefine the prompt again and try to get the correct answer. So again, we can use the same prompt here that we have used before, that works step by step, letter by letter. So let's see, copy this thing here, and we are asking the question that is best. Now we are asking the same question, that how many vowels are there in each days of a week. Now we are saying the model that works step by step, letter by letter. For example, for beta, I want you to write this. So now let's jump on. You can see here the model is producing the answer, and you can easily check. So here's a step-by-step breakdown of the number of vowels in each day of the week. This Sunday is consonant. Sunday, you can see the vowel is U and A. Now it's coming up with the correct answer, that is U and A. And Monday, it is coming up with the correct answer, that is O and A. You can check it manually. And here, Tuesday, U, E, and A. Here you can see U, E, and A, but I don't know why it is considering the Y as vowel every time. I mean, I think it is doing something wrong. And here also you can say Wednesday, E, E and A is coming with the correct concept, E, E and A. But it is considering Y as the vowel again, but no matter, we are getting the answer. So I'm trying to train the model with another perspective, that is, if there are same vowels available in a word twice, then you need to consider this thing also. For example, for B's there will be two E's, and so the total vowels will be 2 here. So let's see if Llama 2 can answer the question. When the prompt is now, whenever I change the prompt, and now he's coming up with almost the correct answer, very close. You can see here, you can check. Sunday is having total 2 vowels, Monday total 2 vowels, Tuesday is having 2 vowels. Yes, the problem is solved. You can see this U, E and A, these are the vowels here, so 3 vowels. Wednesday, I did some mistake here because he was not able to follow the full step here. He came up to this Wednesday, but he didn't complete the things. That's why only and this time we got only one mistake, that is only Wednesday. So this total vowels is 2. And then Thursday again he's coming up with some mistake. The stage is consonant, but he tries to follow this thing, and total vowels equal 2, so U and A. So yet so far he's trying hard to find out the answer of this question, but so let's say if I can try this thing in the ChatGPT, what answer it provides to me. ChatGPT Plus solved the question pretty easily and accurately. I can see here U, A 3 vowels, Friday, I, A 2 vowels. So he has solved this question. So I have asked him that can you come up with the step-by-step process. Then he showed me the process and how he solved the questions. First he identified the vowels, and then he goes for the days, and then I asked the ChatGPT Plus to give me a step-by-step thinking process for that, and he elaborated in this way. So I asked him to make it short, and then you can see here this is the concise version of the thinking process, that first you need to recall the vowels, list days, scan and count and repeat. So here I can copy this thing and let's drop it into the prompt into here, if he can solve this problem. So now I will be asking this question again to this because there is no way. So how many vowels in each days of the week, and then I'll use the ChatGPT thinking process. I will enter this thinking process to here, that here's the concise version of thinking process. This is the thinking process. Now let's see if I run this prompt, if I can get any answer following the process that the ChatGPT has followed. So you can see here Sunday, Monday, Tuesday, Wednesday. But here again he did some mistake, Wednesday 2 vowels. So still there are a lot of improvements to be done. So, and it will be done really quickly, so no need to worry for that. So if Llama 2 cannot solve this sorts of question, that why should we be using Llama 2, or why should we be relying on Llama 2 that much? So don't be frustrated. Let's try another thing. This is a blog. You can see this blog is by Nuteric, and here they are discussing this thing, that is Llama 2 better than GPT models. So 6 main differences between Llama 2 and GPT-4, GPT 3.5 and GPT-4. So it is a big one. You can see it is a huge one. So what we can do, let's try to get the summary of this text. So we'll be taking the whole bit of text up to this, and now let's copy this and throw it to ChatGPT. You can see I have thrown it to ChatGPT. Here, this is the text. I asked the ChatGPT that I want to share some text with you, and you will summarize the key points in bullet points. So here is the text, and I have thrown the whole text here, whole bunch of text I have thrown here, and you can see it's a long one. And whenever I asked this question, And what reply I got from GPT-4, you can see that the message you submitted was too long. Please reload the conversation and submit something shorter. So the message is too long for the ChatGPT, it is saying, and please reload the conversation and submit something shorter. Now let's try the same thing in Llama 2. So in the Together AI playground, I dropped the whole blog, and now let's press this here. Llama 2 is processing, it's running. So here you can see he has made a summary for you, but it was not possible by ChatGPT. So if you read this thing, that I understand that the article is a comparison of Llama 2, GPT 3.5 and GPT 4, three language models that are widely used in natural language processing tasks. So the article provides an overview of each model. Then Llama 2 is an open source LLM developed by Meta, and it has a smaller size than GPT 3.5 and GPT 4. And here you can see, however, it falls behind GPT 3.5 and GPT 4 regarding creativity, coding skills, and token limit. So Llama 2 is a good choice for building a chatbot for a small business, generating social media content, and supporting experienced content writers. So you can see GPT 3.5 on the other hand is a more powerful model than Llama 2 and can handle more complex conversations. So the article also compares Llama 2 to other open source models such as Falcon and MPT, and it shows that Llama 2 outperforms them on most benchmarks. The article concludes that Llama 2 is an impressive option that deserves attention, and it may be only a matter of time before GPTs get dethroned. So overall, the article provides a detailed comparison of Llama 2, GPT 3.5 and GPT 4, you can see. So the main point is that the article concludes that Llama 2 is an impressive option that deserves attention, and it may be only a matter of time before GPTs get dethroned. So you can understand from here that the Llama 2 is going to be a better choice for the future. And we are in the Together AI playground, and Llama 2 was able to summarize a whole huge text, whole blog, you can say. So there must be some reason here why the Llama 2 is being called the future. And if we try out with this conversational dialogue, text summarization, sentiment analysis, and other entity recognition, and I'm sure that it will provide much more good result than ChatGPT. At least it will be similar to ChatGPT, because still it is in the initial stage. We'll be doing some summarization and entity recognition in the next part, but let's get familiar with the models of Llama 2. So here you can see Llama 2 has come up with three models, that is 7 billion parameter, 13 billion parameters, and 70 billion parameters. If we compare among them, here you can see the speed of the 7 billion parameter is exceptionally fast, but its intelligence is basic. You can say the dumbest model among these three. So it's adept at executing straightforward tasks such as summarizing or categorizing content. So ideal use cases would be quick information retrieval and simple prompts or instances where time is of the essence. So for quick information retrieval, simple prompts or instances where time is of the essence. So at that time you can use this thing. And 13 billion model, it is its speed is moderately fast, slightly slower than its 7 billion counterpart. Though it is not that fast, but its intelligence is better than 7B. You can see enhanced cognitive abilities. It excels at grasping nuances, and is calibrated to be cautious about potential offense. The ideal use case for the 13 billion parameters is creativity-driven tasks such as crafting stories, poems, or content that requires a balance between speed and depth. So that means it is artistic. This model has some creativities inside. That's why it can craft the stories, poems, or content that requires a balance between speed and depth. And if you talk about the 70 billion parameters, speed is more deliberate. That means it's slower than the others, and due to its extensive knowledge base, it is slower. In case of intelligence, it's superior, has the most advanced variant. It exhibits profound understanding and analytical capabilities. So if you want to do some analysis works, then you can use this 70 billion parameters. And the ideal use cases for this is engaging in dialogue, solving logical problems, answering factual queries, coding assistances, and other complex undertakings. Though in case of solving logical problems, it is not that much ahead like GPT-4, but it is still in the initial stage. So in very soon you will see that it is outperforming GPT-4, maybe. This variant is the crowd favorite and is the default choice for most chat applications due to its comprehensive expertise. So if you want to make a chatbot, you definitely have to choose these 70 billion parameters for that. So this was a basic comparison among the models. So in the next part, we'll try to show some practical use cases by using the Visual Studio Code and Together AI API. So you can see Llama 2 is here and get it on Hugging Face. So you can use the Hugging Face to install Llama 2, and to read more about the Llama 2, here you can come down, and inside here you can read about the specific models like Llama 2 7B, Llama 2 13B, and Llama 2 70B. Chat models are also available here, so you can go inside this and you can read it out. But by using the Hugging Face, the installation procedure is not that simple. You need to take the permission from Meta AI, and then you need to download the original version. And if your PC doesn't have a good GPU, that is more than 16 GB, more than 8 GB or 16 GB, then you will face difficulty to work with Llama 2. So they have introduced the quantized version. If you get inside this link, that is huggingface.co, the blog Llama 2 7B chat ggml tree main, then you'll get this quantized version of the model that can be used in local CPU or GPU. So you can download the model from here. You can see these are the quantized model that is written Q3, Q4. So you can use this any Q4 version. So why we require a quantized version of Llama 2? Why don't we use the original version of Llama 2 chat model with 7 billion or 13 billion or 60 billion parameters? Let's first look at what is the quantization and what is quantized model. Quantization is a technique to reduce the computational and memory costs of running inference by representing the weights and activations with low precision data types like 8-bit integer instead of usual 32-bit floating point. So reducing the number of bits means the resulting model requires less memory storage, consumes less energy, and operations like matrix multiplication can be performed much faster with integer arithmetic. So it also allows to run models on embedded device, blah blah blah. So the main point is that we are using the quantized version of Llama 2 so that we can run Llama 2 on our own CPUs. And the large language models like Llama 2 or any other large language models, they basically require a lot of computational capabilities, and they are very memory intensive. So what does quantization do? It will compress the size of the memory of the Llama 2 and at the same time accelerate the computation and inference while maintaining the model performance. At the same time, we'll be able to use this thing with lower amount of RAM, that is less than 16 GB. So the installation procedure was there. So I downloaded some of these chat models here. So if you can see here, I have installed this Llama 2 7B chat model, that is quantized 4 model and quantized 8 model from there. But literally I was not enjoying this quantized model because it was taking too much time to respond. Whenever I asked it any question, it took more than 3 to 4 minutes to answer the question. Even with the 7B chat models, it was taking time to respond, more than 4 minutes. And sometimes it is taking more than 3 to 5 minutes. So it is really boring to keep waiting for the things. That's why we will not be using the quantized model also. We'll be using the Together AI API. That will be a better solution, because by using the Together AI API, you will get a faster response, definitely. So let's start this. First, you need to install this pip install upgrade Together. You need to install the Together. But in my case, I have already installed, so I'm not going for this. And we'll be working with LangChain. We'll be doing some summarization and entity recognition at this time. So we'll need to install the LangChain also. So if you If you don't have the LangChain installed, then install this thing by this command pip install LangChain, and here to get the API key you need to move to the Together AI playground, and then just inside the settings option you'll be getting the API's key from here. If you click on that, you'll get your API key. Just copy the API key here, and you can save this thing inside this .env file. And to call this env file, I need to write some code here. So, and we'll be using this Python decouple to retrieve the API key from the .env file, and that's why we are installing the Python decouple library. Pip install Python decouple. We need to import the config function from the decouple. So from decouple import config, and now if you run this line of code, it is asking for the environment you'll be using. So I'll be using the Llama virtual environment. So it is always preferred to use the virtual environment for this for using the Llama 2, otherwise you will face problem because the libraries are continuously updating. So now you can see from decouple import config import together. Now the first thing is that we need the together API key, so we can call the API key by this together.api key, and here's the API key, and you need to call the config module here, and here you will type the variable that you use to save the API key. So in my case it is together API key, so together API key is installed here. Now let's see if our together API key is working. Let's check the thing with. So to check how many models are available inside, we can get inside this models list, and we can get the models name by using this line of code that you can see we have created a for loop, and it will loop through the models and it will print out the index number and the model name. So let's run this line of code. So here you can see so many models are available inside this together AI. So we can use any model here. So definitely we'll be using Llama 270B chat model. So to initiate the model, we need to write together dot models. You can see the models here, and let's start this model. You need to call the start module. You need to copy and paste the model name. You can see here, this is the model name. This together computer Llama 270B chat models we'll be using. So 70B chat models. So our connection is established. You can see the success equal true and the value is here. So now for text generation, I have collected a class from somewhere. That will be very useful to generate text from the context. So let's use this class. You can see this is the class here. This class inherits from the LLM class, which is a base class for all the large language models. So the Together LLM class provides a way to use the Together API to generate text. And we will call this LLM class from the LangChain module that you can see this langchain.llm space import LLM, and then from LangChain utils we need to import the get from dict or environment module. You need to install this Pydantic library for the root validator. If you don't know Pydantic, then you can come here. Pydantic is the most widely used data validation library for Python, fast and extensible. Pydantic plays nicely with your IDE. Define how data should be in pure canonical Python, validated with Pydantic. So basically we'll be using this thing to validate the function. If you come back here, you can see to install this Pydantic, you need to install the Pydantic, you need to move to the terminal, and here you need to type this pip install Pydantic equal 1 and then asterisk. You need to install a Pydantic version that is less than 2, otherwise it will not work, because here you can see this Pydantic model that is greater than 2 will not work with LangChain. So you should install model less than 2. So I'm installing any model that is 1 point something. Whenever the Pydantic is installed, we'll be importing the extra and root validator library from here. Now get inside our Together LLM class. What is there? Let's check. The Together LLM class has the following properties, that is model, Together API key, temperature, and maximum tokens. The model is the name of the together model that we'll be using, and together API key will take the API key, and the temperature, that is the sampling temperature to use, and the maximum tokens is 512. That we are using 512, but we can increase this thing to get a longer output. We can even use more than 1000 tokens here, no problem. So this model attribute specifies the endpoint to use for the language model. This config inner class restricts the addition of extra fields to the class, so you cannot add any extra fields. That's why we're restricting it by calling the extra class extra.forbid here, and then we have the root validator. Actually, this function checks if the together API key field is present in the values dictionary. If it is not present, then the function gets the value of the together API key from the environment variable. If the environment variable is not set, then the function raises an error, so there is no chance of missing the API key. So this is the main thing of this function. The LLM type property returns the type of the language model, which is together. You can see it is returning together. The call method here, this is the main function, and it sends a prompt to the together API and retrieves the generated text. It sets the API key. You can see here the API key is set, and then it calls the together complete create method and extract the generated text from the response. You can see here from the outputs it is collecting only the text, so you'll be getting only the text whenever you'll be using this function. This models and maximum tokens temperature is already defined. You can see here we have defined this thing on top of this. So mainly the call method makes the actual API call to together using the together Python SDK. It passes the prompt, model, temperature, etc., and it gets back the generated text. So main function is this. So in summary, this allows encapsulating calls to together API in a simple class while managing settings like the API key, model, and parameters. The generated text can then be returned to the caller, you can say. So this function is ready, so let's run this code. So this is okay now. Now let's call the together LLM class. We're calling the class here, and we're inserting the model as together computer Llama 270B chat. Temperature is 0.1 and maximum tokens is equal to 512, and together LLM, you can see I'm naming this LLM as Tog LLM, so run this piece of code also. Now let's check the Tog LLM model. So let's check the Tog LLM together LLM model. What is the model it's using? And let's run. Yes, you can see the model is together computer LLM 270B chat, so it is okay. And if we want, we can check the temperature also. Let's say Tog LLM dot temperature, enter, and you can check the temperature. You can see the temperature is currently 0.1. That means our together LLM is set. Now let's ask the model a question. Why don't we ask a question? Tog LLM, just here you can put the input question that who are gladiators. Let's see what's the response and how much time it requires. As we are using this 70 billion chat parameter, it will take some time, but it will not take that time like the original. So here you can see we have got the answer after 14.3 seconds. The answer is gladiators were professional fighters in the ancient Rome who engaged in mortal combat with each other. Wild animals are condemned criminals. So there are so many things written here. It is nice. But if you notice that we have got the answer nicely, but we have got some new line characters with that, so we need to remove these new line characters from the text. So for that purpose, we can use the regular expression that we have used before. So for that, we need to import the regular expression. So here, let's say, just import RE, regular expression, and inside this together LLM class, I need to bring some change. Instead of returning the text in the output, you can see we're inside the call method function. There is the output, so we need to change it from here, and here we'll be changing this thing that we'll be using this regular expression here. And we'll be using this regular expression substitution to remove new lines, that clean text re.sub. We are calling the re.sub method. It will change the new line character with the empty space. So then we need to return the clean text here. So cleaned, and then it will return the clean text. So the function is modified. Now let's run this code again. And now together LLM is 13B chat. We are using the 13B chat. And now if now let's run the code and let's check. Yes, now it has removed the new line characters, so that's great. So gladiators were professional fighters in ancient Rome who engaged in mortal combat with each other. So that's nice. So I think it's really good to look at. Here you can see we have got the response within 13 seconds, but if you have used the original model or the quantized model, then it would have taken 3 to 4 minutes at least to get the response. So just by using this together API key, you can make the process faster and get a faster response. So now we'll be talking about system prompt. System prompt is a fairly new concept in prompting, especially it is applied in Llama 2. System prompts are a way to control the behavior of a language model like Llama 2. They are prepended to the prompt and the model will understand your request without having to be told in every prompt. For example, here you can see you could use a system prompt to make Llama 2 talk like a detective. So you would set the system prompt to "you are a detective," and the model would understand that you want it to respond in a detective-like way. So previously we have used these sorts of prompting in case of ChatGPT, and we have instructed him to act as a detective, act as a poet, and every time whenever we are giving instruction to the model, we used to provide him with a context that you act as a detective, you act as a poet, something like this. But here you don't need to say this thing repeatedly every time you go for a prompting. So this is a nicer way. And you can also use system prompts to make Llama 2 behavior in a more professional way. So try system prompts like act as if you are responding to documentation questions or you are responding to highly technical customers. So here are some tips for writing system prompts that keep them as short as possible. Use clear and concise language, avoid using pronouns, and then use the inst and /inst tags to mark the beginning and end of user input. We'll be talking about this very soon, so let's forget this for now. And then here is an example of a well-written system prompt. You can see here this system prompt: "You are a customer service chatbot. Assume the customer is highly technical." Then this system, you can just enter the system prompt and the model will react as a customer service chatbot. And this system prompt tells the model that it is a customer service chatbot and the customer is highly technical. So this will help the model to respond in a way that is appropriate for that situation. So here is an example of poorly written system prompt. Here you can see as you can just write that "I am a chatbot." This is also a system prompt, but this system prompt is too vague and doesn't provide any instruction to the model. The model will not know how to respond to this prompt. So now in the Python code, how will we apply this system prompt? Let's jump into this. Here you can see one example that the system prompt can be like this: "You are an advanced assistant that excels at translation," and instruction would be convert the following text from English to French. So this is the instruction and this is the system prompt. But whenever you are using the Llama 2, you cannot just write the system prompt and instruction in this way and the model will not understand what are you saying. There are some codes for inputting the system prompt and the instruction. And there are some rules you need to follow. You can see here your instruction should start with beginning of the instruction and end of the instruction tag. These tags are like this. This is the beginning tag and this is the ending tag. So you need to keep your instruction in between this. Otherwise the Llama 2 will not understand what is your instruction. So it may fail to repeat with the correct answer. and then you can see this is the beginning of the system and end of the system, and it will start with this system tag. This is the tag, you can see system tag. It will start with this and it will finish with /sys, you can see here. So you need to keep your system prompt inside this inside these two tags, otherwise the model will not understand how he should react. So let's move to an example to understand it clearly. That day I was reading a blog and I found this example pretty interesting. Here you can see, if you are writing a chat app with multiple exchanges between a user and Llama, you need to mark the beginning of user input with this tag and end it with this tag. So now here you can see they are creating a chatbot, and user first said hi, and hi is kept inside this instruction model, and then hello, how are you, it was said by Llama 2, and then again the next instruction was I'm great, thanks for asking, could you help me with the task. So you need to prompt in this way. This is the instruction that I'm giving, this instruction you need to follow. Now what happens if you try to change this thing? If you try to change this thing, let's say here they used a different syntax like user and assistant. So here they used user hi and assistant hello, how are you. Now they have asked a question that, okay user, I'm great, thanks for asking, could you help me with the task. But now the model answered that okay, that input is incorrect. So the prompt is incorrect and the system prompt is not there. So you need to definitely you need to define the system prompt and the instruction clearly, so that it becomes easy for the model to understand. Then let's say we are continuing the conversation in this way. So what mistake can happen? Now we are following this syntax, that user and assistant, user assistant. So then a user said that how much wood could a woodchuck chuck, or something like that. The user asked this question, then you can see in the output the Llama 2 replied that the prompt is incorrect and the system prompt is not there, is not present there. So but he replied with an answer, you can see. My assistant, haha, well, a woodchuck would certainly be able to chuck some wood, but if you are looking for a more straightforward answer, it depends on the size of the woodchuck and the type of wood. A small woodchuck might only be able to move a few sticks of firewood at a time, while a larger one might be able to move a whole log or two. Is there anything else you'd like to know about woodchucks or their ability to chuck wood? So you can see that answer is not correct. So, and the model completely failed to read the inner context of these sayings. Now if you put this in a correct way, that now we are putting this thing inside this instruction, that how much wood could a woodchuck chuck or something like that, and then the model replied that okay, prompt is a correct prompt and the system prompt is okay. So now here you can see the answer to that famous tongue twister is a woodchuck would chuck no wood. That means now he understood that we are talking about a tongue twister. So it's a play on words and not meant to be taken literally. Woodchucks, also known as groundhogs, do not actually chuck wood. They are burrowing animals that primarily feed on the grasses, clover, and other vegetations. So now the model was able to catch the inside humor that was lied deep into the context. Now let's come back to here. Now how will we put our prompts? So here you can see this is the default system prompt inside the Llama 2 model, that you are a helpful, respectful, and honest assistant. Always answer as helpfully as possible. While being safe, your answers should not include any harmful, unethical, racist, sexist, toxic, dangerous, or illegal content. Please ensure that your responses are socially unbiased and positive in nature. And if your question does not make any sense, this is this. So this is the default system prompt. But definitely you need to change this prompt whenever you are using it in a different context. And for that we are creating the get prompt function, and this prompt function will take the instruction and the system prompt. Here you can see we have kept the system prompt inside this beginning system and end system, and we have created the prompt template. and inside this we are keeping the system prompt and the instruction. Both things are required, so we are keeping this thing here. Then the function is returning the prompt template. So this is our main prompt template. And now we are declaring the system prompt here that you are an advanced assistant that excels at translation and convert the following text from English to French, and we are putting our text here. This prompt template is ready, that is get prompt function. We are calling the get prompt function and passing the instruction and system prompt here. Then we are asking for printing the template. Now let's check our prompt template. How does it look? So for that we need to run this line of code, and then let's print the template. So this is the correct template that we are using. We have kept the whole things inside the instruction, and the system prompt is here. You can easily see inside this system tags, and the instruction is here, convert the following text from English to French. So this is the correct template. Now we can do one thing. We can import the LLM chain and prompt template from the LangChain. So first thing, so now we'll be working with this, and now let's active this thing. Yes, now this will be the final prompt. We'll be inserting the whole template inside the prompt template, and the input variable will be text. So we'll be inserting some text now to check if it is working. Call the LLM chain here, and I'm naming it as LLM chain of the LangChain. So LLM chain equal LLM chain, this chain, and here the prompt would be equal prompt, and LLM equal, here we'll be using tog LLM. This is the LLM. Now let's ask the LLM chain some questions. So here is the text. You can see the text is it's too hot today, and the output would be LLM chain.run text. So LLM chain will push the text inside the prompt template, and then it will start working. So let's print the output here. Let's check. So here you can see, here is the translation of it's too hot today from English to French. That is Alfred Trop Chaud, and I cannot pronounce the letter things, so you will pronounce on behalf of me if you can. So the thing is done. So now the model has done the translation from one language to another. So that is great work. So now the template is ready. So in this way you can change the system prompt and the instruction, and can play with it. So now the template is ready. So in this way you can change the system prompt and the instruction, and can play with it. I'm not making the template again, just showing to you that instruction is summarized the following article for me in bullet points. And here you can see it will take the text from the text input, and then here is the system prompt. You can see you are an expert in summarization and expressing key ideas. And the template, you can know we're using this get prompt function. Instruction is there, system prompt is there, print template. Now we'll be calling the LLM chain, and LLM change the same thing we did here. Let's run this piece of code. So here you can see our instruction is all inside this instruction tag, and the system prompt is again inside the system tags. So that is that's fine. So now let's provide the text here. Text will be defined here. So let's come up with a huge one. So let's go for something from the website. So let's go for Winston Churchill. Let's learn about Winston Churchill from the website. Let's say we are getting inside the Wikipedia, and here so many things are written. I want to take a huge context just to check the power of Llama 2. So you can see this is a huge one. So let's stop here, and I'll be pasting this inside this. So this is a huge text, you can see. So you can see there are commas and inverted commas. So That's a problem. So what can we do? We can put this whole things inside a triple quote. You can see the size of this text. It's a huge one. Keeping it inside the triple quote. Now this has turned into a string, and now we can run our text. So our text is ready here. And here you can bring back the LLM chain. So again, LLM chain will push the text to the prompt template, and it will print the output. Let's see what comes as a result. It's a big one. I think the summary will be huge because the context is huge. So we have got our answer in bullet point. You can see here, Winston Churchill was a prominent figure in British politics and history, serving as Prime Minister during World War II. And then you can see Churchill became Prime Minister in that age, and Churchill was a prominent leader in the world. He was a prominent figure in the world. Churchill. Now, if you check at the last part or in the middle part, you can see this model failed to produce correct answer. That is, it has produced some repeated answer here. He was prominent leader. He was prominent leader in the world. So it's not a good way of expressing. So what can we do? So 13b is failing. So we can change the model. Let's say we can change the model to 70b, and we can increase the token size. So token size can be 1024. We can increase the token size like this. You're asking the model something to do with the same prompt, but if you increase the temperature, then the variation of the answer will be much more like this. Maybe with the high temperature, in 100 times it will respond in 100 different ways. That is better. If you want to add some creativity, then you can increase the temperature, and if you want consistency, then you can keep the temperature low there. Now let's run this piece of code, as we have changed our model to 70b, and the context is huge. So we have got a response. But in May, Churchill spoke against the government's decision to recognize the annexation of Austria, and in June he warned that Germany's next move would be attack on these. So this is not actually correct. So we need to modify our prompt here. I think we need to change the prompt in a different way to get the answer. Let's change our instruction. So I'm going for a different instruction here. You can see this is the instruction. I'm changing the instruction. I think this prompt is better for getting the summarization. Write a concise summary of the following text, delimited by triple back quotes. Return your response in bullet points, which covers the key points of the text. And you can see here is the text, and I'm writing that bullet point summary. So this is the instruction, and this is the instruction that I'm using. And then system prompt, I'm using that you are an expert in summarization and expressing key ideas in bullet point. I've changed the system prompt here that you are an expert in summarization and expressing key ideas. So we are keeping like this. So now we're running this code. And now let's run the text, and let's try if we get the things in bullet point. Sometimes you need to change the prompt and try out if it works. Yes, now you can see I have got something concise and written well. That you can see Winston Churchill was born on November 30, 1874 at this palace, and he was the grandson of this, and Churchill was an active child and enjoyed physical sports. He was sent to a preparatory school. Then everything is in a bullet point. You can see he was commissioned as a cornet in the 4th Queen of Hussars, and then he was tasked with overseeing Britain's naval effort when World War I began in August 1914. You can see, so Churchill returned to the House of Commons in 1916. So all the important things are noted here, and here you have seen that I have changed the prompt and it worked. So you need to write it nicely so you can remember this prompt, that okay, write a concise summary of the following text delimited by triple back quotes. So you can use this instruction for your summarization. This will provide you with better summarization. That's why prompt engineering is compared to an art. I think you can try your creativity here. You can change the quotes, You can change the instruction and try out with different things, and at some point the model will come with better answers. So now let's try out something more. Now let's go for entity recognition to check what's happening inside this. So here again I am changing the instruction that detect named entities in following text and delimited by triple backquotes. Return your response in JSON format with spans of named entities to the field named entity type and span. So I want the named entity type and span, and return all entities and text, and this will be a JSON format file. And system prompt, now I need to change the system prompt that now you are an expert in summarization. Now you are not an expert in summarization. Now you are an expert on in entity recognition, and you can find entities correctly from the huge texts. And then template is get prompt instruction system prompt. This is okay. Same thing. Our prompt is nicely placed inside the instruction. Now I need to input my text equal. So we can change it like this so that it doesn't conflict with others. The text entity, and here I can write the text entity. Let's go for Amazon Wikipedia. Let's search this Amazon company, and we'll be trying to find the entities from this company. It's a huge one, so let's try with this much, not going for the big one. It will work for the big text, but I'm trying out with a small one here. Let's see, text entity. So here again I need to put the things inside this triple quote so that it doesn't face any problem. So this is the text entity. Run this text entity, and the last thing is that now we need to call the LLM chain to push the text inside. So this will be the output. It's okay, so print the output now. Let's see what happens. I have to change the text entity here also, though I have changed the name of this. So this is the text entity here. Now let's rerun the code. So it has taken a huge time here. You can see it has taken almost 53 seconds, but the answer I think hopefully is correct. Here you can see this named entity is Amazon.com, and its type is company, its span is start 0 and 19. That's great. And the named entity is Jeff Bezos. This entity type is person. The span is start 23 and 32. Meta, this Facebook company, formerly Facebook. This type is company, span is 76 and end. So it has come up with some sorts of span and is correct. So a Twitch type company, IMDb type company, Walmart type company, and here Amazon Prime. This is a Amazon Prime. This is a product, you can see. So almost correct everywhere. Kindle is, and here you can see the Kindle is a product, and the Echo is a type of a product. So it is matching correctly, I think, almost correctly. So I just fixed one thing just now in the summarization part. You can see I have asked the model to make a bullet point summary. So the model made the bullet point summary, but it was kind of like a whole bunch of paragraph. Then suddenly I remembered that we have done some edit before. If you can come back here inside this together LLM class, we did something. If you can remember, we removed the new line characters with empty space. That's why we are not getting any new lines on the output. Now I have just changed this thing, and I have asked the model to return the text. Now the presentation is much more nicer than before. If you can see, much nicer than before. Here you can see I have asked for the summarization, and now the whole summary you can check from here. It has come in a more presentable way, that Winston Churchill was born in November 13, 1874. Then Churchill was an active child and enjoyed physical sports, something like this. Now it looks nice, isn't it? He was elected as the Conservative MP for Oldham in 1899. So all the information, all the life story is almost there. And the model is here saying that I hope this helps. Let me know if you have any questions or need further clarification. Now it is way better to look. So you can just remove the new line characters whenever you need, or whenever you need this sort of response, that time you can bring the text on. And in case of entity recognition also, I have tried the same thing, and now the output looks much better. Let's come here. You can see here, this is the entity. Now it truly looks like a JSON format that Amazon.com. Type is companies, pan is start 0 and end 9. So that is nice, isn't it? Amazon Web Service, this is company, Zook's company. So now it looks way better than before. So try new things, you will find so many things interesting. So we were planning a vacation to Honolulu, Hawaii, but we are in a doubt after coming to TripAdvisor then which hotel should be best suit for us. That's why we are searching the TripAdvisor and there are so many hotels, so I am really confused which one to choose for me. And that's why I want to hand over the process to Llama 2, and Llama 2 will make a data-driven decision for us that whether we should stay in this hotel or not. Let's say I chose this Hotel La Croix, and you can see there are 2096 reviews. So if you get inside this Hotel La Croix, then you can see that there are so much informations. You can come down here. Someone said that it is excellent and 4.5 rating. It is excellent and it has 2096 reviews. So here they have written the reviews: the excellent, very good, average, poor, terrible. So 1571 people reviews that it is excellent, and someone said it is terrible, that the number of people is 42. So now the problem is that we don't know why they have said this is terrible, or we don't know why they have said this is excellent. So that's why we want to deep dive into the reviews, and then Llama 2 will come up with a data-driven decision for us that whether you should stay in this hotel or not, what is the main benefit of this hotel, and what are the bad things you will face if you choose to stay in this hotel. So here you can see there is one review that we booked Corner Studio, the location okay. Here you can see some issues from other reviewers that leaking toilet, bathroom, barn door without lock. So he has written about so many problems that, and someone said that is amazing. So here you can see their reviews. It is not possible to read all the reviews because there are so many reviews available. So what can we do? So we want to gather the important information from the reviews, and we want the help of Llama 2 to decide whether we will be staying on this hotel or not. So for that purpose, let's start our journey. The first thing is that we need to scrape this thing. So this time we'll be scraping as many reviews as possible. So now for the web scraping purpose, we'll not be using the Selenium, we'll be using the Playwright, and this from the Playwright Sync API, we'll be using importing the Sync Playwright option. If you don't have Playwright installed in your system, then you can just install this thing by pip install Playwright and pandas, and then definitely we'll be using OpenPyXL. First we'll be using this Playwright. So what is Playwright? This is also a same thing like Selenium WebDriver that will help you to scrape the page. So let's go and check about Playwright. So you can see Playwright enables reliable end-to-end testing for modern web apps. So if you go to the Python section of Playwright for Python, then you get started. So Playwright was created specifically to accommodate the needs of end-to-end testing. Playwright supports all modern rendering engines, including Chromium, WebKit, and Firefox. We'll be using the Chromium here to test on Windows, Linux, and macOS, and I'm using Windows. And you can use it in a headless mode or in headed mode, whichever you prefer. So this is mainly used for testing, but at the same time it is pretty handy for web scraping also. So we'll be using this thing today. So we're creating a function here first, and that is main function, and with sync playwright as p. So by using the sync playwright, we'll be doing a synchronized API call to the web browser. So for that, the first thing we need is the page URL. So here's the URL. This is the URL, Hotel La Croix. So Hotel La Croix. So this is the URL. So let's copy the URL and come back here. And this is the page URL. This is the URL we'll be using. Then we'll be using a browser. So we'll be using the Chromium browser. So you can call this p.chromium. And in here we'll not be using the headless mode of the browser. So that's why here I can say that headless equal false. Now in here you need to define the page equal to, you need to call the browser. This you need to call the Chromium browser, and this will scroll a new page. This will crawl a new page and new page. Now the page is ready. And now let's instruct the page to go to that URL. So this go to, and he will get inside this page URL. This is the page URL, and if you want you can fix a timeout here. Timeout should be 60,000, you can say like this. Here the timeout is actually 60,000 milliseconds, that means 60 seconds, so that is okay. And one thing I forgot to tell you, that whenever you will install this Chromium, whenever you are using this playwright for the first time, that time you may not have the Chromium installed. So if it is not installed, then just go to the terminal and type playwright install Chromium. Otherwise you may face problem in launching Chromium. Now we'll be scraping the reviews. So for that we can create a variable reviews, and we can ask the page to scrape certain items, and for that we can create the locator. We could call the locator method. So this locator method will enable you to locate the things you want to scrape from a page. So what things we require? Let's move to the browser and check. We want these reviews only, because we will not be dealing with the other things. So for that let's inspect this page, and let's click on there, and we want this review, the whole page we want. So this div we want. So if I can move there, so actually we want this div, we want the XPath of this. Here you can see this all are the same class. You can go there, down, and here if you click this is the next one, this one, and then this one, and then this one. So they all belong to the same class. So we need this div container. So we need the XPath of this div. So let's copy the XPath and copy XPath, and let's move here and get inside and just paste this XPath here. So this is the locator, and it is pretty difficult to understand the XPath from here. So I have a pretty easier option for this. If you have ever done the scraping, then you know this XPath will not work maximum of the time. So that's why you need to do it manually. And the first thing is that which tag you are using. Just write down the name of the tag. If you don't know anything about the XPath, then I'm doing it for you. First you need to put the double slash to this will indicate that you want all the items, you want all the divs that have the following class. So you can copy the class from there. Here you just need to type that @ class, that will indicate you are looking for this class, and you can paste the thing. We need to keep this class inside the inverted comma, otherwise it will not be understandable. So Control X, and now here I'm keeping this thing inside the inverted comma. So it does mean that you locate the div with this class. So in this way you can write the XPath. I think it's not so difficult, not too difficult to understand. And now what we need all the divs. So you can just type div all. So this will scrape all the review cards for us. That means the whole review card you can see. So let's check first how many reviews are there. So I'm using this function, print function. There are that many reviews are there, so it will be printed inside this Python files. So I'm not using the Jupyter notebook. You can see I'm using the Python file here. So let's save this thing. I just want to check how many review cards are there. Reviews card are there. I didn't close this. I didn't initiate this function. Otherwise, it will not work. So you need to initiate the main function. You have just written the function, but what the function will do, it is not confirmed yet. That's why it's showing this thing. So this function will auto run. So now let's save this thing. Now come back here. So you need to write this line of code that if name equal main, then run main. So this function will auto run now. So now let's run this Python file again. Here you can see we are not using the headless mode. That's why we can see the pop-up, and there are 10 reviews. It has come here. So that means our locator is okay. So our XPath is working, and there are 10 reviews. So we can create a reviews list here. Reviews list, and this list will, after crawling the page, will store all the reviews here. And now we'll create a for loop that will look through the reviews. These reviews. So here we can write for review in reviews. For review in reviews, I need to do something. We'll create a review dictionary, and inside this review dictionary, inside this empty dictionary, we'll store all the texts of the reviews. So here inside this dictionary, we'll be saving the texts in a key value pair. So here in this case, the key would be review, because we are collecting the individual review here. From where we'll collect this thing? We'll collect this thing with the help of page locator. So inside this page locator, you need to define actually what you need. I need only the text, inner text of the reviews. So here, this is the option. So let's say I want only this. I want only this text, nothing more. Read more. This review is so huge to read. So, but I want only this portion. I don't need the other informations like the name or other things. I don't require now. I will only work with the reviews. You can use the locator to locate this thing and inspect now. So if you click on that and go here, you can see this is inside the span tag. But we will not use the span tag. We can go a little up, and we can use this deep class. I think if I go there, here, yes, we can use this deep tag, deep, and the class is this. So just copy the class from here, page locator. So we'll be searching this thing with the help of div. We need all the divs. So let's try div. How will you be finding this thing? You will be using the class element for that. So class spaced. This is the class we require. So we will go through this. So this is the value. So that means this is the value, and we need the inner text. So we must write this thing, that inner text we require. The key will be the review, and the review text will be the value. So we'll store all the things as a key value pair inside a dictionary. Now let's say if you want to save the name of the author of these reviews. If you want to save the name of the author of these reviews, like that here, Tony B, you can save this thing. You can create another key value pair, and you can write this thing like review dict, and you can instead of review here, you can say that this is the author, and you can use the locator to get the name of the author, and then you can store this thing inside the dictionary as a key value pair for further use. If you want, you can add these things into the store, but at present I only need the reviews, so I'm working with the review now. Now we need to add this thing into the review list. Now let's append the reviews list. Dot append with the dictionary. So now the reviews list will not be empty, it will be fulfilled. So as simple as it is. And then just say return. You need to return the things, otherwise it will not return. So let's print the reviews list. Print reviews list to check if it is working. And, oh, I did one mistake here. Actually, we will not be going from the page locator here. We did the page locator, we did it earlier, but now we'll be going from the review. I'll find the locator. I'll further narrow it down, because we'll be now entering only to the review card, and from there we'll be finding the locator. So yeah, I did another mistake that I need to put the return at last, because print reviews, I don't need this here. So we'll do the return later, but here I want only the reviews list. So for that, now I think hopefully it will work. Let's run this code. So here we have got the reviews list. You can see first we have got the number of reviews, that is there are 10 reviews, and from here the reviews started. The crew and front desk people were very attentive, especially Wendell, James, Mila and Zendia. So let's check if it is coming in a nice manner. Yes, yeah, it was able to scrape the first. It was able to scrape the first review, that is the crew and front desk people were very attentive. So the same thing. And then if we check the second one, that is the service was excellent in any way, especially Wendell guy. So if we go back there, and here we can check the next one. Here the next review starts from here. The service was excellent in any way, especially Wendell guy. So we were able to collect all the reviews here, so 10 reviews. Now we were successfully able to scrape the page, but this is not our intention. We need to scrape, but our objective is to scrape multiple pages. So for that purpose, if you come back here and if you notice that this is the second page here, if I click on the third page, then you can see something is changing in the URL, that is 20 here. Reviews are 20 hotel, and if I go for the fourth page, let's see. So if I go for the fourth page, then it becomes 30, and if I go for the fifth page, it should be 50. So let's check. Yes, it should be 40. So here you can see whenever we are moving to the next page, 10 reviews are being added here. So what can we do now? We can write a function to scroll all the pages, or maybe if 5 to 10 pages, just to check if things are going well. So let's come back here. Now instead of printing this thing, we'll be returning the things from this function. So return, and here, so we can bring all the things inside a function up to this, up to return, and just cut this thing and create a new function, that is def get reviews. This function will take the page as the parameter. First you need to paste this thing, whole thing. Now the whole thing is inside the function get reviews, def get reviews, and here you can take the page as the parameter. So here is the function, this is the get reviews function, and first thing is the page URL, and then the browser page, all the things are remaining same, no changes. So this function will return a reviews list. And if you have a close look at this, the number 10, 20, 30 will be changing here. It will be changing whenever we'll move from one page to another. So we need to give it a dynamic. So we need to make it dynamic. So for that we can just add a parenthesis here, and inside the parenthesis I will add page, and this is the parameter we are using. So we are keeping the page parameter as a dynamic thing, and here this line should be kept inside a function. So for that we are keeping it inside a function. Now let's say we want to scrape the data for the first 5 pages. So for that we can write one function outside of this, and this should be outside the function. You can write it here that for x in range, let's say we want to scrape first 6 page. So for that the range should be 0 to 50, and here we can use a step, because you can see with every alteration, I mean with every page change, if you move to page 6, then you can see the reviews of the hotel changes to 50. So whenever we are changing this page, the count is increasing by 10, so we can add a step here. That step can be and should be 10. So that means the 4x in range is 0, 10, 20, 30, 40, 50. It should be like this. You do something. Now what I need, I don't need anything. I just want the get reviews function to be activated. So this get reviews function I need, and which page I require, I'll enter this x pages. So in here this x means 0, 10, 20, 30, 40 and 50. We'll be scraping 6 pages here, and this get reviews function will return the reviews list. So we are just doing this thing, and as we are working with the get reviews function, we need to keep this reviews list outside the function, otherwise we'll not be able to catch this thing. So we are keeping it as a global function, as a global variable here, Control V, reviews list. And another thing, this browser will also work as a global variable, so we need to keep this browser also outside the function as a global variable. So this is okay. Now let's run the script and check what we get. So here there are some problems. So I think this is from the first page, so I'm facing some problems to scrape the first page actually. So let's start this thing. Let's start this thing from 10 to 15. I think this will work. We'll be scraping from the second page, and this will be easier because the structure of the first page URL doesn't match with the others. If you come back to the first page, you can see here nothing is mentioned. That's why the crawler is not able to catch this page, and it is causing some problem. So it no matter, we'll be scraping from the second page, and we'll scrape the first page individually if required. So let's coming back here now again, try. Yes, you can see it is opening every page and scrapping through. So now it's okay. So there are 10, 10, 10, 10. That means 40 reviews. Okay, that's good. If we want, we can get some more. So why don't we? There are 40 reviews, but it is not returning anything. It will not return because we are not printing the list. That's why we are not getting the list. But actually, from here you can see there are 10 reviews, 10 reviews, 10 reviews. So it is scraping the pages, and it is stocking inside the list folder. So after scrapping the reviews, what can we do? We can put it into a Punter's data frame, and then we can export it as a CSV or Excel file. So for that, so here you can see I have created a data frame, and this data frame will take the reviews list. And then I have converted this data frame into an Excel file, and into again I have converted this into a CSV file. So now if I run this, and after running the code, we have got this CSV and Excel file here. You can see this review list 1 and review list 1 CSV and Excel. If I check the reviews list, here you can see all the reviews. So here we have almost 51 reviews. So now our reviews are available as a CSV and Excel format, so it will be better for us to deal with. So it will be easier to analyze the things now. So I have opened a new Jupyter notebook, and here we'll be asking for a data-driven decision from the data that we have scraped just now, that is the review list 1. So for that, the first thing that we need to call is the together class. So this is the class, so I can copy the whole thing from this together API class. Up to this I can copy. So copy the file, and here just paste the thing, and here you can see you need to import the decouple and config, import together. So you need to import the together API key first, and for that you need all those things. We'll be using the Llama 270B chat here, together model start. You can see together model start this Llama 270B chat, and here is the together, and here is the together LLM class that we have just created before sometimes. And then this is the main function. This function will generate a text output, and here you can see the text output here. And we'll be using the together LLM model, that is Llama 270B chat. Temperature is 0.1 and maximum tokens I have increased, that is 1024. This is the beginning of the instruction and the end of the instruction. And here is the system prompt, that is the default system prompt, that is you are helpful, respectful and honest assistant, and blah blah blah. So we'll be changing this default system prompt. We'll not be working with this. And then we have the get prompt functions. This prompt function will take the instruction and the new system prompt as the parameter, and it will return the prompt template so that we can check if our prompt template is inside the instruction tags. These are the whole things. So let's run this piece of code, and here you can see all the things are okay. The first thing we need to do is to load the CSV file, and to load this file, we can load this file by using a LangChain document library. So here we can call this from LangChain dot document loaders. You can see here is the document loaders. So from document loaders we need to import CSV loaders. So CSV loaders, this CSV loader, the capital one, so I need this CSV loader, and now we need to call this CSV loader. So let's create a variable that is called loader, and this now we need to call this CSV loader, and we need to clarify the file path. So we need to define the file path here. So what is the file path? Review list is my file. So here you can see review list 1. At the same time, you need to mention the encoding here. So we are using this UTF-8. That is the character encoding. So we can just mention it here that the UTF-8 encoding we're using. So encoding is CSV. Encoding is UTF-8. So it's okay. So we can now keep it as a text. So here you can see you can just call the loader to load the file, loader.load, and the loader will load the file. Now if we want to check the text, then we can then we can check the converted text, that is print.text. Let's run this piece of code, and here you can see we have got all the, there is a document, page content, review, very friendly staff and cost facility. So document, you can see this is the review. So all the reviews, he has taken all the reviews, and these reviews are now inside the, and so now the CSV loader has converted the whole thing as a text, and you can see it from here. It is a huge one. It consists of almost 60 reviews here. So now we have got the reviews as a form of the text. Now it's time to provide Llama 2 some instructions. So let's see here. This is the, now we are changing the system prompt and the instruction here. You can see that the system prompt is you are an advanced assistant and you are always helpful in times of research. So here is the instruction. You can see find out the reviews from the text, recognize all aspect terms with their corresponding sentiment polarity in the given review, delimited by triple quotes. The aspect terms are nouns or phrases appearing in the review that indicate specific aspects or features of the product or service. Determine the sentiment polarity from the options positive, negative, neutral. Answer in the format aspect sentiment without any explanation. If no aspect term exists, then only answer an empty list. So here is the text inside the triple quote. This prompt is an exclusive one for finding the sentiment, for doing sentiment analysis. So I have not created this prompt. I have found it from here. You can get inside. I got this thing from a GitHub file. You can see this is called evaluation of ChatGPT on information extraction. Here I've seen there's a few prompts that are very useful. If you get inside this for APSA, and inside this you have the prompt folder, and inside this prompt folder, if you get inside, you will get the JSON format file. Here all the prompts are written, and these prompts are really helpful if you want to use. You can see here this recognize all aspect terms in the given review. which are nouns or phrase appearing in the review that indicate specific aspects or features of the product. So I'm using this thing for my review analysis, and you can use this thing and you can use the others also. You can see this recognize all opinion terms appearing in the given review. All the prompts are really useful in case of aspect based sentiment analysis. So whenever you will be doing something like aspect based sentiment analysis, that time you can come here and collect the appropriate prompt for you and then ask the Llama 2 to do the other things. So we are using this prompt here that find out the reviews from the text. So our instruction is ready now, and template is so the prompt template is here, and here you can see our LLM chain is ready. So let's run the code to check if our prompt template is inside the instruction. Yes, our prompt template is inside the instruction tag, and the system prompt is also defined nicely. Now call the LLM chain and let's see how the review look like. So here I have created a variable that is reviews variable, and this reviews variable is nothing. This is actually calling the LLM chain to run the text, and then we'll be printing the reviews. So here is the instruction, that is, here actually we are calling the Llama 2 to go through the reviews and do a kind of sentiment analysis and come back to us with the report that is positive, negative, and neutral. So for that, let's run this piece of code. Now here you can see we have got the reviews here, that inconvenient, negative, great, positive, unbearable, negative. So the model has collected all the phrases that are related to positive or negative sentiment. So you can see here regular housekeeping, negative, request for kettle and iron ignored, that is negative, expensive for quality of a hotel, that is negative. So there are all the positive and negative things are here. So if you can check that neutral information is there, it was fine, so it's okay. So we have got somehow about 64 reviews. So from there, now it will be easier for us to make a decision that whether should we stay there or not. So we'll not be taking the decision, it will be taken by Llama 2. Llama 2 will provide us some sorts of decision out of these reviews, that's which thing is good and which thing is not good, whether you should stay or whether you shouldn't. So now the main job for Llama 2, that is, we are changing the system prompt again, that you are an advanced assistant. You are always helpful in terms of research and instruction. You are an advanced assistant. You are always helpful in times of research. So instruction is that make a report from the reviews, calculate the positive, negative, and neutral reviews, and make a decision for me whether should I stay on that hotel or not. Reviews are inside the triple back quotes. So reviews are, you can see the reviews are inside the triple back quotes. So now I'm asking the Llama 2 to make a report from the reviews and then make a decision for me whether should I stay on the hotel or not. And now the template is ready, that is get prompt instruction, system prompt, print template, and then prompt template is also ready. And here inside the prompt templates, the input variables should be reviews, not the text. So you should change here that we are taking the reviews as the input variables, and the LLM chain is ready. The prompt equal prompt, and LLM we are going to use the together LLM, so no need to change here. Now then we are calling the LLM chain to run. Normally we go through the text here, but in this time we are going through the reviews. So the report and the final report should be printed out. So let's run this piece of code. And in here you can see we have got the answer. It took a little bit of time, but we have got the answer. So here was the instruction: make a report from the reviews, calculate the positive, negative, and neutral reviews, and make a decision for me whether should I stay on the hotel or not. So based on the reviews you provided, from here the Llama 2 started answering that sure, I can help you with that. Based on the reviews you provided, here's the breakdown of the positive, negative, and neutral reviews. Positive reviews are 24 and negative reviews are 31 and neutral reviews are 6. From here also you can make a decision whether you should move or not, but actually 24, 31, so it's pretty close actually. So Still, it's really tough to make a decision. So let's see whether Llama 2 says then. Based on the majority of negative reviews, it seems that the hotel may not be the best choice for you. Many reviewers mentioned that the hotel is overpriced, the rooms are small and outdated, and the bathrooms are not well maintained. Additionally, some reviewers mentioned that the hotel's location is convenient but also noisy due to road noise and homeless people yelling at night. So that's the problem. The homeless people will be yelling. So if you if you want a quiet place, it is not that quiet as you are expecting. And on the other hand, some reviewers mentioned that the staff is friendly and helpful, and the hotel has a great location. So location is good. So the location is great, and the staffs are really friendly and helpful. I have seen this review. I have seen this in a few of the reviews. Ultimately, the decision to stay at this hotel or not is up to you. If you are looking for a hotel with a great location, friendly staff, and don't mind the small rooms and outdated amenities, then this hotel might be a good choice for you. So if you're looking for a hotel with great location, friendly staff, and don't mind the small rooms, then you can go for this hotel. It should not be a problem. But however, if you're looking for a hotel with more modern amenities, larger rooms, or a quieter location, then you might want to consider other options. So great. So now it is pretty much easier to make a decision out of these things. You can see here, if you want modern amenities, larger rooms, and quieter location, then you must avoid this place. This is not a good choice for you. But if you want friendly staffs, great location, and don't have any problem with the small rooms or outdated amenities, then it can be a good choice for you. You can move there and you can have your relaxation time. Wow, the Llama 2 has made a great decision for you. If you love this sorts of thing, then you can go there and stay, and if you don't want a noisy place, then you can avoid this thing. So now I think this decision will conclude our hotel search. So if you come back here inside of this hotel search, then you can see there are many reviews. There are positive and negatives, average, poor, and it's not always possible to read through the whole reviews. It's so long and huge. So we can always take the help of Llama 2 and ask him to create a data-driven decision for us, so that we are not in a lost project. So if you are in a doubt to choose which location you want to stay, then always you can leave it to the hands of Llama 2, and the Llama 2 will come up with a good decision, as far I think. So welcome to a new project. This project is for data preparation and query. Here's the project scenario. The system takes a screenshot of document or a web page or an invoice, etc. The screenshot is uploaded to a designated folder. The process starts by using OCR technology to read and extract the text from the images. Once the text is extracted from the images, the script goes to work and constructs prompts based on the content it found. The constructed prompts are sent to another AI system called Llama 2. After Llama 2 processes the prompts and generates responses, the results are sent back to the application. The application can store these results for further analysis or use them to perform specific actions based on the content of the web page or an invoice. So let's make the thing easy. Actually, what we'll be doing, let's say we are in a web page of the World Bank, and we have all the information of Denmark here. This social information, you can see the poverty head count and the most recent value, and the trends are here. So all the informations you can see from here, the total population and economic growth, environmental information, institutional information. So all the information is there. Even there are some drafts regarding the projects and operations, finances. So what will we do? First, we'll take a screenshot of the whole page, and then we'll collect the data from the web page, and we'll prepare the data for further analysis. So in this stage, we'll be doing the data preparation, and when the data preparation will be done, it will look like something like a CSV or Excel file. You can check it out from here. The whole thing will be look like this: that indicator, most recent value and trend, You can see here also we have the indicator, most recent value and the trend. So we will collect all the information from here and turn it into an Excel file, and at the same time also we'll query the web page, and we'll ask him different questions regarding the data in the later stage. So you can see here we have this indicator, most recent value and trend. You can see the trends are in pictures, in images, but still Llama 2 was able to find the accurate assumption for the trends. You can see here the life expectancy at birth. This is increasing. So from the graph also you can see the life expectancy at birth is increasing, and the total population, if you check, the trend is also increasing here. So if I check that, the population is also increasing. So this is fabulous. So we can try, and the project will be interesting. So here we'll be working with this data, that is the World Bank data of Denmark. So for that purpose, the first thing is that we need to scrape the whole page. For that purpose, the first thing that we need is to install the Pillow and Selenium, and you can just go to the terminal and type pip install Pillow and Selenium, and it will be installed. If you don't know about the Pillow, then you can check it here. This Pillow is a Python image library, adds image processing capabilities to your Python interpreter. Though we'll be working with the screenshot, so we need to install this Pillow, and this is a handy tool for image processing. So we'll be using this Pillow and the Selenium WebDriver. So the first thing is from Selenium you need to import WebDriver, then from webdriver.com.by you need to import the by, and support WebDriver support UI you need to import WebDriver wait function, because sometimes we need to wait for the page to load. Then from Pillow we need to import the image library, and we need to import the time. And the first thing is that we need to define the URL that we need to take the screenshot from. So our URL is this one, this data.worldbank.organization, and country is Denmark. So then we need to install the WebDriver, and you can use Chrome WebDriver or Firefox WebDriver, either one, the one you want. And installing this thing is pretty easy. If you don't know, just I'm showing you that. Just type Chrome WebDriver, and here you can, from the download section, you can install the latest one, that is the Chrome WebDriver 114. So if you want, you can work with Firefox also, and you can install the Firefox WebDriver, but I'm working with Chrome. And after installing this thing, you need to define the path, in which path it is, the folder is remaining, so just keep it here. And then the next thing is to set up the WebDriver. In here we are setting up the WebDriver. The first thing is, you can see here, options equal WebDriver.chrome options, and then we need to set the driver in a headless mode so that it can prevent a window from popping up. And now here we are defining the driver, WebDriver.chrome, and here we are defining the executable path, that is the WebDriver path, and the options is option. That means we are using the Chrome options here. Let's load the page. Deprecation warning. So headless property is deprecated. Instead use add argument headless or add argument headless new. That means headless property is deprecated, so we need to change this option headless. What we can do, we can remove this. So here you need to write just this thing, that options.add argument and headless equal new. So this will enable the headless browser mode. So let's try. And here also you can see another error, that is webdriver.init got an unexpected keyword argument, that is executable path. So let's forget this. We don't need to write it in this way. We can just simply write it in this way, that driver, we can call the WebDriver, and that Chrome options equal web options. That means our options is that means we are using the Chrome options from here. Now I think it will work. So now let's run the code. So yes, so this is the modern version. Our driver is working. Now to load the web page, we can use driver.get a URL, and then we can take the screenshot by driver.save screenshot, and we need to specify the URL. We need to specify the folder where we want to save, and I want to save this thing inside a folder named saved, and inside this saved folder I will save the things, and the name of the screenshot may be denmark.png. so as we are working with Denmark file, then this, now if I run this thing, our screenshot should be saved inside the folder. Let's check it out. So it's done, 7.5 seconds, and here we can check the saved folder, and here is, this is the denmark.png file, and we have got our screenshot. But this is not what we want. We want a full page screenshot, but we have got only this view, but we want all the information. So we want the Selenium WebDriver to scroll the whole page, then take the view of entire page and take the screenshot of the entire page. To do this thing, we need to write a different function, and this will be a Lambda function. So let's try this thing. So we don't need this sort of screenshot, so let's remove this, and we can use this Lambda function. So here we are executing a Lambda function, and this Lambda function will allow the driver to execute this script, and this script will scroll through the whole document body. That means it will scroll through the entire entire document, because the body tag means the entire page. If you can come back here and inspect, then in here you can see this is the body tag, and if I hover my mouse over there, then you can see it is selecting the whole page. So that's why we need to select the body to scroll. So now the Selenium WebDriver will scroll through the body. And then the next thing is that you need to define the window size. That means which window size you will choose. Inside the parameter, we are declaring the height and the width. That means we want the full height and full width of this web page. And now another next thing is to define which tag you want. So let's say driver.find element. We want to find the element by tag name, this tag name, and here you need to put the tag name, which tag you want to find from there. Since we want the full page, so our tag should be this body tag, so we will be using this body here. Just write body, and now after getting the tag, what you want to do, we want to take a screenshot. So here you can tell the driver to take a screenshot, and you can store the screenshot somewhere, and we'll be storing the screenshot inside the saved folder, and the name of the screenshot should be denmark.png. So this is okay now. So now we can, and I think now we'll be getting the entire screenshot, and finally whenever the screenshot will be taken, then the driver will quit, and this is the whole code. But before that, let's clear the old screenshot. I'm deleting this thing, and now let's check it out. Let's run the code. So we have come up with some source of error, that is string object is not callable. So actually we did some mistake here, the driver.find element by tag name. Oh, it should be, I did the mistake here. You should not put it in like this way, by tag name. Then you need to define this body inside a string, not inside the bracket. So this find element will take two parameters. The first parameter is a type, in which way you want to find, that is by tag name, and then which tag you want to find, that is body. So these two parameters you need to classify. Now run the code, and this time we are able to take the screenshot, and let's check the screenshot here. You can see this denmark.png. So inside this, and you can see the whole page is there. So it's not looking good, but I can increase the size. Now you'll be able to see the things. Here you can see the screenshot of the whole page, that starts from here with the Denmark social, economic, environment, institutions, and project and operations, and you come down. We asked for the body tag, that's why the driver didn't take the screenshot of the footer, and we don't require this thing. Let's say I want to see and open the image, then we can open the image like image. You can do, I can call the image library from the pillow. Then I can call the open method, and here you need to write the path of the documents you want to open. I want to open the saved and the denmark.png. This file I want to open, and I want to show this thing to you. Then just write image.show. It will show to you the image to you. So let's operate this, and here you can see again I'm able to see. So this is the image, the World Bank image, and so now we need to read the text from images, and for that purpose we need to install the PyTselect library. So this PyTselect library is an OCR tool as far I know. Here you can see the Python tselect is an optional character recognition, that means OCR tool for Python. That is, it will recognize and read the text embeddings in images. It is also useful as a standalone invocation script to tselect, as it can read all images, image types supported by the Pillow and Leptonica imaging libraries. So, and we are using the Pillow library also. So that's why this PyTselect library would be a good choice for us for the OCR text extraction. And let's come back to this Visual Studio Code, and here pp install PyTselect and import PyTselect. So we are importing this thing, and sometimes you can find that tselect is not included in the path, and if the tselect is not included in the path, then you need to install it manually. And you can download the file from here. You can see this PyTselect, and after this is the source distribution, and you can download this from here, and then you can define your path in here, and like this, that pytselect.cmd, and then in the location of your path you need to define where is your tselect.exe file located. So you just write like this, it will work. But normally if you install this thing with pp install pytselect, path will be automatically mentioned there, so you don't need to write this thing. So the next thing now is to write a function that will allow us to read the image from the text, and this function will take the parameter that is image path. This function reads text from an image file using tselect OCR, and its argument is that image path, the file path to the input image, that means where the image is located, and it returns a string, that means the extracted text from the image. So this is the simple thing. So to load the image, you need to call the image function of from the Pillow library, and then you just instruct him to open this path. So already we have done this, and use this tselect OCR to extract the text from the image. So now I'm calling the PyTselect, and this PyTselect has a module called image to string. So this image to string library would extract the images from the string, and here to take the image as the parameter. Now this function is ready, but we need to define our image path. Maybe I didn't create the image path variable. For that, image path inside this saved folder, and the name is denmark.png. So this is ready. This is the image path, and now I can write that we want the text, so we can write it as text. And now we can call this function that read image text function, read image text, and inside this function we need to put our image path. Now let's print the text. So print text, and let's check it out what comes. So here you can see that whole text is here. It starts from this Denmark, jump to overview by theme by SDG goal graph. So, and then here is the indicators, topic, income level, high income, region Europe and Central Asia. If I can poverty hand count ratio 2.5 dollar a day. So if I come back to the main page and if I check here, you can see this poverty hand count ratio at 2.5 $15 a day. So it is extracting the text, that is true, and though it is not looking good, but we can provide it a shape later on. But we successfully scraped the text from the page, that is the thing here. Now we can call our class that is called Together AI class to check the whole thing. So I'll not be writing the whole class. Let's import the class from somewhere. So here is the Together AI class I'm calling. If you cannot remember, I'm just repeating it shortly for you. First, we need to import the decouple, and from the decouple, we need to import the config, and then import together. And typing, we need the pydantic library. It is important. From the pydantic library, we need to import extra and root validator. That is very important. And then, so here are the things. So first, we need to call the together API key, and then we need to initiate a model. Which model you want to start? So we'll be using this Llama 270B chat here, and then we have defined the class, that is together class. And you can remember this class takes all the properties like model, API key, temperature, and maximum tokens. And then here you can see the root validator. Root validator validates the API key, and main function is this call function. This will take a prompt. From the output, it will generate the text in this line, and at last this function will return the text. Here we have defined our LLM. This is Tog LLM. We are using the Together LLM. Here is our model, temperature, and maximum tokens. That should be 1024. I have increased the token. By using Together API, you can increase it up to 4000 token maybe. I'm not sure, but it should be. And we can bring the default prompt also here. Just copy paste. You can see this begin instruction and instruction, and the default system prompt is here, that you are a helpful, respectful, and honest assistant. And then we have created our get prompt function, that instruction new prompt is like this. And then we have created the new get prompt function, and this will return the prompt template. So I think you can remember all those things, so I don't need to repeat this again and again. So let's ask some question first to check if everything is working well. So here we can ask this question, that what is the annual population growth? So let's come back here. So I have changed the system prompt here, that you are an advanced assistant and you are always helpful in times of research. So now we are asking this question. Here is the text. This should be the text. So we will input the text here as a dynamic prompt. So you can see, if you can remember, the text is coming from here. This is the text. So we are inserting this text in a dynamic way here. You can see this is the text. So here I am asking the model this question, that what is the annual population growth of Denmark? Find out from the text, and we have provided the text here, and we have provided the text here. And the template is get template, and we are calling the get prompt function, and we are passing the instruction and the system prompt as a parameter inside this get prompt function, and our template is required. So from the LangChain we are using this prompt template, and inside this prompt template we are passing this template. So if we check our template, let's forget this, and if we check our template now, then you can see this is the template, this is the instruction, and this is the system prompt. So all these things are inside this instruction tag, so it's fine. And now we need to declare the prompt and the LLM chain. So the prompt is prompt template, template equal template, and it will take the text as the input, you can see. And the LLM chain is ready, and we are using the Tog LLM as the large language model. So Together LLM. Now in here we can call the output. So output equal to LLM chain dot run the text, and now print the output. So let's see what outputs it provide to us. So here you can see the answer, that is according to the World Bank's data bank, the annual population growth of Denmark is 0.8% as of 2022. So if I move here, you can see This is the population growth, annual population growth, and this is 0.8, and the information is from 2022. So that's great. So here you can see another question. If you want, you can ask, there is net migration. So things are interesting. So let's come down and ask some more question here. How many individuals using the internet? So we can ask this question. So copy and come back here. So let's ask this question: how many individuals are using the internet? Find out from the text. So let's see. So according to the text, the percentage of individuals using the internet in Denmark is 99%, and scale is 0 to 100. And the information was collected in 2021. So if you check it back, so that is really impressive. Yes, it is coming up with all the answers. So in this way, you can ask as many questions as you want to the model, and I think you will get the maximum correct answer. If the web scraper done a perfect scraping, then it will not be a problem to provide correct answers. But though these trends are in an image form, so you may not get the correct answer from there, but we'll still try to make an assumption on the basis of the information provided. So let's So now it's time to prepare the data. So we want to prepare the data, that's why we want to make a table out of these informations. Let's say we have some information here that indicator, most recent value, and trend. So we have all this information here. You can make an Excel sheet or a CSV file that will help us to go for data analysis or something later. So that for that purpose we need to prepare our data from the here. So how we can do this thing? We can give Llama to some instruction to prepare that table for me. Then we'll try to improvise a little to keep the database good shape. So let's try to prepare our data, and for that the system prompt remains same, that you are an advanced assistant. You are always helpful in times of research. And then here I have changed the instruction that make a table with 3 columns like an Excel sheet with border. The columns will represent the indicator, most recent value, and trends from the text. You will write the trends are ascending, descending, or stable only. Here our text is ready, prompt template is ready. So let's run this piece of code. So yes, we are so our instruction is well formatted, and now let's call the LLM chain to run the output. So here you can see our table is ready, and here's the table with 3 columns representing the indicator, most recent value, and trend from the text. So here is the 3 column. Though it is not looking so organized, but at least it is inside the column. You can see this indicator is property headcount ratio of $2.15 per day, 0.2%, and the trend is decreasing. If I check this thing, you can see the trend, this poverty headcount ratio, this is decreasing in a decreasing mode. You can check it from there. In 2019 it was 0.3, and in 2020 it is 0.2, so the trend is decreasing, so it is correct. And then life expectancy, if I check, and clearly it is saying this life expectancy at birth is increasing. So if I go for that, here I don't need to go for this also. You can see the trend is clearly increasing. And then population, it's also increasing. Yes, the population is increasing, and population growth is 0.8%, and it is stable. So population growth is stable, actually 0.7 it was the growth in 2016, and it's 0.8, so almost stable. You can say it's not that far, because in 2019 it decreases, and again 2022 it increases to 0.8. so you can say by seeing the overall graph it is in a stable mode. So now you can see how much powerful the Llama 2 is. It is catching the information from the images that is not mentioned even in the text. I think, I don't know how he is finding this thing. It's a huge improvement in case of artificial intelligence. So now that's a great data, but if you can recheck this thing if you want, because I don't think that almost all the things will be accurate, and there may be some mistakes there because this information is being taken from the images, and it is really hard to capture the information from these sorts of data. So our output is ready and it's looking really nice, but we cannot work with this thing. We can put it in a database like Excel or CSV, then it will be better for us. For that purpose, we can do one thing. We can change the name of this output. Let's say we can change this thing as raw data. So we can say this is raw data. We want to print this raw data and we want to save it in a file. So for that, we can add another parameter, that is file, and you can see what will be our file. Let's write it something now like F. So F will be the file. So we didn't declare the F yet. So for that, we can declare the F here. Let's say F equal, we want to open a file. So let's say open, and that means a new file. So give it a name that is txt. We can save it like this. And what we want to do with this file, we can add another parameter, that is if you want to read or write this. So we want to write this file, not only readable. We will change something if required. That's why we are keeping it as a writable format. So in this way, we can create a text file in our directory. But as we have opened the file, we need to close the file again. That's why after printing this, we'll be closing the file. So after close, and this is completed. So now if I run this piece of code, then let's see what happens. It is collecting the data from the text on top. So yes, it's okay. So we are not getting anything here because the output will be saved inside the file, not in the Jupyter Notebook printout. So we can go for this. Let's search this thing. Where is it? So here you can see this raw data.txt file. So if you get inside this, same thing that we have just got as a printout, now it has been saved as a text format and in a text file. So what we can do, now we can convert this thing into a pandas data frame, and we can try to export it as a Excel or CSV format. So let's try if we can do this thing. That will be nice. So for that purpose, we need to import pandas. So let's import pandas. I have the pandas already installed. So if you don't have the pandas installed, then you need to install this thing, import pandas. And then inside this, I am creating a data frame. And for the data frame will read the text file. So I'm instructing the pandas to read the table. As we will be reading the text file, so we can use this read table method, and here you need to put the directory that you want him to read, that is raw data.txt. So he'll be reading this file, and I want to see how does it look. So let's code. So you can see here's a table with 3 columns representing the indicator most recent value. So it is not in a good shape. So what can we do? This heading we don't require, so we can change the heading from the text. We can remove the heading from the text. So let's go inside this raw data.txt file and remove this heading. We don't require this, and keep it like this. And then here also this note is not required as we are changing this thing. So inside this note, you can see that model has already mentioned that the trend is based on the available data and may not reflect the correct situation. The data is from 2020 or the latest available. So let's change this. Let's remove this thing. Now come back here and let's run this code again. So here you can see indicator, most recent value, and trend. It's okay, it's looking nice, but still not in a good shape. So here we can indicate the separator. So to indicate the separator, here you can use this separator. parameter, and you can declare the separator. So the separator is this. So now the pandas data frame will be able to show it nicely. Yeah, now you can see, but there are 5 columns now. It is looking okay, almost okay, but there are 5 columns now and 2 columns. So what are the unnecessary columns? That is unnamed 0 and unnamed 4. So we need to remove this thing. Come back here, and what can we do? We can create a new data frame Denmark, and this data frame Denmark. Now from the previous data frame we need to drop some columns, and for that we can define what columns we need. So this is the column name. We can just copy, Control C, and paste it inside this inverted comma. So in unnamed 4, so we'll be removing these 2 columns, we'll be dropping, and here you need to define the axis also. So axis equal to 1. Then now I want to get the TF Denmark data frame. So let's run this thing. Now it's okay. You can see here indicator, most recent value, and trend. So it is looking nice. Now this is inside this pandas data frame, so we can start working with it. Now if we want to do some sorts of data analysis, then we can easily use this thing. Now why don't we export this thing in a CSV format or Excel format? So for that we can write some piece of code here. So this is the data frame, Denmark data frame, and I want to change it to Excel, to CSV first. Okay, let's say to CSV, and then so what should be the name of the file? Let's say denmark.csv, and here if you want the index, and yes, I want the index, so I can write it index equal true, and yes, index equal true. And the same thing I'll be doing here again. TF Denmark, I want an Excel version also, so to Excel EX, here's the Excel version, and then I want to convert it in what would be the name? This should be same thing, denmark.xlsx Excel file, and here if you want the indexing will be there or not. Yes, there should be indexing, and index equal true. So now I think we'll be able to see it in the CSV and Excel format. So here it is inside this CSV file. You can see it is ready, and the Excel file, this is also ready. So but we cannot see it from here, so better we can go to our directory to check. So if I open this thing, you can see this is nice. So I can increase this, and here you can see the trend indicator, most recent value, and trend. So if you want to give it a good shape, then you can give, no problem. I don't require this line, so I'm deleting this thing, delete, and then from here it starts indexing, indicator, most recent value, trend, and let's check something from here, that which one is stable, that is population growth. Yes, I can see this population growth is stable, and international homicides, if you check, this is decreasing. So let's go for this to check international homicides. Here is international homicides, so yes, it is decreasing. It is almost stable. So here this answer is not almost correct, but the approach and the assumption is okay. So you can use, but individuals using the internet, this is increasing or decreasing. You can check here. Individuals using internet, this is increasing, and there is no information regarding central government debt. So if I come back, statistical performance indicators, central government and debt, yes, there is no data. So he's saying that there is no information. Though it's not 100% correct, but you can use these sorts of ideas to scrape any web page and come up with and prepare your data for any kinds of analysis job. So that was our main purpose. So we were able to do this thing by the help of Llama 2, and we use the OCR tools to get the data from here. So this is really an impressive use case of the Llama 2, I think. So do your analysis now and try to do some data preparation out of your own interest. We are going for a new project. You can see here there are several books. There are 4 books here. And the first one is 7 Habits of Highly Effective People, and it was written by Stephen R. Covey. And this is a renowned book and always inspiring for the people who wants to achieve success in their life. This book is a great inspiration for the future leaders also. And the next one is Outliers. This is also a bestseller, the story of success. So you can see all the books are related to success. And the next one is Shoe Dog. This is also from a famous man. He's the creator of Nike, and his name is Phil Knight. This book is also an inspirational book. Who are those seeking for success, or who are those want to achieve a high level of freedom in their life, then they can read this sort of book. And the last one is here. You can see Thinking Fast and Slow. This is by Daniel Kahneman, and this is also winner of the Nobel Prize in Economics. So all the books are representing the same niche, that is success and leadership. So in our projects, we'll be questioning all these 4 books in the same time, and we'll be using the Llama 2 for the questioning purpose, and Llama 2 will create the answer for us, and we'll try to compare all 4 books, and we'll try to find some interesting facts about the books. We'll ask different questions like whose writing style and narrative voice did you find the most compelling, who structured their book in the most engaging way. Or we can ask this question that after reading these books, what excites or concerns you most about the future of leadership? How could the next generation push these ideas forward? So we'll ask these sorts of questions to Llama 2, and we will see how the Llama 2 reacts in these sorts of questions. These 4 books are really huge in text, so it will be a huge context, and if Llama 2 can come up with some sorts of correct answers, then it will be really impressive. So let's move for this project. And here as a tech stack, we'll be using the following things here. First, we'll be using the PyPDF loader. This will help us to load the PDF files. We'll be loading the 4 books by using this PyPDF loader. And then after loading the PyPDF loader, we'll divide the text in several chunks so that we can query several parts easily. And for that purpose, we'll be using this recursive text splitter from LangChain. This recursive text splitter will split the text in several chunks. After that, from these chunks, we'll be creating embeddings, and for that purpose, we'll be using this Hugging Face embedding. Previously, we used the OpenAI text embeddings to create the embeddings, if you can remember, in the prompt engineering course. But here we'll be using the Hugging Face for the embedding purpose, and we'll be using this BG base EN model. This BG base model is a good one. We'll be creating 768 dimension vector dimension embedding, and after creating the embeddings, we'll be storing this thing in the Pinecone embedding database. Then by using the LangChain, we'll query the Pinecone embeddings, and to get the best suited answer, we'll be using Llama 2, because Llama 2 is really good for a huge context query. And to check the power of Llama 2, we'll be using multiple PDF files, so that we can check how efficiently it works. So this is the main objective of our project, so let's jump into it. The first thing that we need is the document loaders from LangChain, and from the document loaders, the first thing we need to import is the directory loader, because you can see here my directory is this book. My books are kept in this books directory, so we'll load the books from here, and that's why we need this directory loader. Then after this directory loader, my books are in PDF format, so for that purpose I need this PDF loader to load the PDF files. And if you have the books in text format, then also you don't have any problem. You can use this text loader from the LangChain document loaders. This text loader can load the text file, so it's not a big deal. Then we need recursive character text splitter from LangChain text splitter, because this recursive character text splitter will help us to divide the text into several chunks. And we need this retrieval QA chains, question answer chains, to query the embeddings, and for that purpose this retrieval QA is must, and we are importing these chains from langchain.chains. So these are the things. Now let's load the files. So for that my files are in this books directory, so I have called the directory loader. This directory loader has taken 3 parameters. Here you can see in the first parameter I have mentioned the directory location, in which location you need to search. So this is the location dot books. You can see here this is the location books. So in the books file you need to search. So I have just mentioned this thing in this way. There are several files, but which files you need to search? So I need to search all the PDF files. That's why I use this asterisk before the PDF. That means you search all the PDF files inside this books directory. So these are pretty easy things. You need to mention it inside the globe. Then you need to define the loader class, which class you want to use, and for that purpose I'll be using this PDF loader. PDF loaders are normally used to load the PDF files. If you want to load the text files, then you need to use other text class, other loader class. So now our loader variable is ready, so we can call the loader class to load, and we are saving it as documents. So run this piece of code. So our document is loaded. You can see here this it took 43 seconds. So if I want to check about the documents, then I can check the length of the documents. Let's check the document length. This is 1338. So currently the length of the documents are 1338. So you can see that means the documents are clearly loaded. Now let's define our text splitter. So we'll be using this recursive character text splitter. So let's call this recursive character text splitter. This is the recursive character text splitter, and here you need to define the chunk size. So chunk size, I want to keep the chunk size as 2000 characters, and you can fix the chunk overlap also. And chunk overlap you can keep it as 200. If you're not aware of the chunk size, then that means where are we splitting the text in several chunks, because it will be cost saving for us. Whenever we'll be creating the embeddings and we'll be querying the embeddings would be in short chunks, and it will be easier. It will not cost too much token from your side. It will be easier to question this short passage or paragraph. That's why we are dividing it in several chunks, just to save our cost. Though we'll be using the free models, but if you use any paid model like ChatGPT or other models, then you have to incur a huge cost if you question or query a huge text or huge chunk size. So that's why we are keeping our chunk size inside 2000 characters. So now we can write it as docs, and we can create another variable as docs, and here we can call our text splitter to split the texts. So here you can split the documents, and our documents is here. You can see already we have created the documents. So now this text splitter will split our documents in several chunks. Here we can check the length of the docs, that means how many chunks, and we need to check how many chunks it will create. That's why we're using this length docs to check the chunk amount. Let's see. So here you can see this recursive character text splitter has divided our documents in several chunks, that is 2289, and each chunk size is less than 2000 character. We can check one chunk if we want. So let's check the chunk number 10. What is the text in there? You can see this document. Here is the page content. You can see the 7 habits of highly effective people, and used to have these are deep problems. So here you can see some new line characters are available. That's why it is not so clear, but we'll be removing these new line characters from the text later. But at present you can see here are almost 2000 characters in each chunk, and you can check the metadata here, the source from which book it is coming. It is coming from the 7 habits of highly effective people, and it is from the page number 6. That means it's working. That means it's great. And if we want, we can, let's say, check another chunk, that is 2200, and go for that. So here you can see we have got another chunk of text. This is 2200, so it should be the last book. And here inside the metadata you can see the book name is Thinking Fast and Slow.pdf. So this is the last book, and the page number is 472. That means all the 4 books are there inside these 2289 chunks. So now our text chunks are ready. So in the next part we'll be trying to create our embeddings. So now it's time to convert our text into vector embeddings. So for that purpose you need to install these things. You need to install the bits and bytes, accelerate, and transformers. You can see here you need to run this line of code, pip install bits and bytes, accelerate, and transformers. And then in this time we'll not be using this OpenAI embeddings, we'll be using the Hugging Face embeddings. And for that purpose we need to call it from langchain.embeddings, import Hugging Face embeddings. So how to use this Hugging Face embeddings, as we didn't use this Hugging Face embeddings before. Move to the Hugging Face block section, and here there is a nice block that is getting started with embeddings. So if you don't know about the embeddings, then it is written here, understanding embeddings. So we already know what is embeddings. An embedding is a numerical representation of a piece of information, for example text, documents, images, audio, etc. So it's just a vector representation of any kinds of text format. Once you understand this embedding, you will be able to build everything from search engines to recommendation system to chatbots and a whole lot more. You don't have to be a data scientist with ML expertise to use them, nor do you need a huge leveled data set. So you can read this blog, getting started with embeddings. How can you get started with this? How can you get started with this Hugging Face embeddings? And then how can you embed a data set? You can see here the first step is selecting an existing pre-trained model for creating the embeddings. We can choose a model from the sentence transformers library. But here you can see they have seen one use case here, that model ID is sentence transformers, and they're using this all mini LM-L6 version 2 model. This model is good for using for small purposes, and you can use it almost anywhere, and because it is small in size, so that's why you can use this model. But we'll not be using this model. This model here. We'll be using a more efficient one, that is from BI. If you don't know BI, this is Beijing Academy of Artificial Intelligence. They have created this model, and this integrates well with Llama 2. And if you come back here, you can see this is the flag embedding. This model name is BGE base EN, and we'll be using these flag embeddings. And this flag embedding can map any text to a low dimensional dense vector, which can be used for tasks like retrieval, classification, clustering, or semantic search, and it also can be used in vector database for LLMs. So in our case, we are doing this semantic search kinds of job here, and we'll be also doing some sorts of retrieval jobs, because we'll be retrieving the data whenever we'll be querying the embeddings. So these two things will be done here, and for that purpose we are using this flag embedding. And if you come back here, this model, you have the BG large model and BG base model, small model. Anyone you can use. The small model is a good one for use, but we'll be using this BG base model. You can see it's ranked second in MTEB leaderboard. This sort of model can run on any kinds of CPU. You don't need to go for GPU. That's why this model is really effective whenever your PC or your CPU or GPU is not that much powerful. That time you can use this BG base model, and this is mainly used for query instruction for retrieval. You can see here this is mainly used for representing this sentence for searching relevant passages. So we'll be searching through relevant passages, so we need this thing. And for installing this thing, you can just use pip install flag embedding. To use this embedding, you need to install this flag embedding. So you can run this command pip install upgrade flag embedding. It is better to install this first, and then you can. Here I'm writing the model name, that is by BG base n. You'll get the model name here. If you come here, this by, yes, this is the model name, by slash BG base n en, and then come back. Here we are defining the Hugging Face BG embeddings model name equal model name. That means our model is this one. So let's run this piece of code. So it has come up with some warning that the installed version of bit 10 bytes was compiled without GPU support, so 8-bit optimizers. It's just a warning, so you can avoid this thing. We don't need the GPU support. We can run this model in CPU format, so ignore this warning. And now first check if our Hugging Face embedding is working. So for that purpose we can just create a variable that is check, and check. We'll be checking the model, that is embeddings, and from here will be embed query. We can call this embed query, and we can call this embed query method, and inside this embed query method you can just type something, that how are you, and if we want to get the embeddings for this. Now let's print out this. Let's print the length of this, length check. So we are checking the embedding length first. We'll convert this how are you text into a vector embeddings, and then we are checking that what is the length of the vector embeddings. We are checking the length of the vector embeddings to be sure that this embedding model is working properly. So let's check it out. 768. So this is the length of the embedding. That means our Hugging Face embedding model is successfully working. Now we need to store our embeddings, and for that purpose we are using this Pinecone database, and I'm here inside the Pinecone database dashboard, and you can see you need to create an index here. So in the free tier you can create only one index, not more than that. So I'm creating my index now. So let's create the index. Let's give it a name like source embed. You can give it any name if you want. And dimension, here we need to use 768 as dimension, because then it will match with our embedding model that we are using. Then you need to keep the metric as cosine. We will not be using the Euclidean matrix, so we'll be using the cosine theorem. So this is okay. Our pod type, here you can do nothing. If you want for a higher plan, then you can buy this S1, P1 or P2 plan, but in my case I'm using the free plan, that is the starter plan. So it's almost ready. Just click on create index, and then this index will be created soon for you. So in here you can see the dimensions and the environment. So we need to copy the environment from here. Now to connect it with the Visual Studio Code, we need two things. One is the environment and another is the API keys. So we need both the things from here. Just copy the environment from here, and then you can paste it inside the .env file. Inside the .env file to keep your keys secured. I have set this thing as Pinecone environment. By using this operating system os.environment.get, we can call this Pinecone environment from the .env file. And then we need the Pinecone API key, and to get the API key you need to move here, and you can just move inside this API key section, and here this is the value of the API key, and you can copy the API key from here and do the same thing, move inside the .env file and same this thing as Pinecone API key. And later on you can call this thing by os.environment.get Pinecone API key. So our Pinecone API key and Pinecone environment is ready. Let's run this piece of code. We have declared the Pinecone API key and Pinecone environment, but we didn't yet establish any connection with the Pinecone client. So for that we need to use this line of code, that pip install Pinecone client. So here you can see inside this PyPy there is a Pinecone client 2.2.2. This is the latest version. So by using this command, that pip install Pinecone client, you can install this thing in the Visual Studio Code. So here I have just installed. You can see this pip install Pinecone client. You can see from here. So you can use this line of code to install the Pinecone, and then you need to import the Pinecone. So for that purpose I'm importing the Pinecone. Import Pinecone here, and so Pinecone is imported. Now we need to initialize this thing. To initialize the Pinecone, we need to use this pinecone.init method, and it will take the API key and the environment as the Pinecone API key and the Pinecone environment. So already we have declared this thing here. If you run this line of code, then it will establish a connection with Pinecone and with Pinecone database. And then here we are mentioning the index name, that our index name is source embed. You can check it from here. This is the database index source embed. So this is our index source embed. Now it's time to create the text embedding. So for creating the text embedding, we can use this line of code. What it takes, you can see. So for that purpose we need to use the pinecone.fromText methods. This fromText method will take 3 parameters. The first one is the text chunk that we'll be using for embedding, and then the embedding model here. This is the embedding model. In our case we are using the Hugging Face embedding. If you move a little bit up, this embedding here, you can see we are using this Hugging Face BG embeddings, and the model name is this Pi, and we are using the CPU as our device. So yeah, you know these things. So this is the embeddings, and where we want to store the things. We want to store the thing in a specific index, that is the Pinecone index. The name of the index is source embed, you can see here. So these 3 things are required. The first thing is the text chunks, embedding models that we are using, and then the index name there. So inside the source embed index we don't have any vector embeddings, because here you can see the vectors are 0. So if I try to run this piece of code, if I try to embed my text, then what happens? Let's see. So now here you can see this source inside the source embedding, our vector embedding is created, that is 2289 vectors. So why there are 2289 vectors? If I check this thing, so I need to come back here, and if I go on top, then you can see here here we have split our whole PDF documents in 2289 chunks, if you can remember, by using this recursive character text splitter, and we have created individual embeddings for each of the chunks. That's why there are 2289 chunks at present. So if you can come back here, then you can see this. There are 2289 chunks, and you need to use these 768 dimensions for the model that we are using. So make sure you are using these 768 vector dimensions. Once your vectors are ready, then you can question it several times by using the query embeddings. You don't need to load the vectors every time you are going for querying. If you already have an index inside your project, then what can you do? If you have the data, then what can you do? Then you can load this thing by using this command. Then if you then text embed equal pinecone dot from existing index. From existing index, you need to call the index name and the embeddings model. We are using the Hugging Face embeddings model, embedding models, and the index name, you can the index name is the source embed. So you need to put the index name as a parameter and the embeddings, and then from existing index you can query. No need to create the embeddings repeatedly. So mind this thing. Otherwise you may insert the same thing twice or thrice. So to avoid this thing, you need to call this vector embeddings from the existing index if your index is already there. And one thing I forgot there, you need to import this pinecone from the LangChain. This pinecone is coming from LangChain. So you just use paste this line of code, and from LangChain vector stores you need to import this pinecone. Make sure you're putting capital P, otherwise it will not work. So let's run this piece of code. Now to check if our embeddings are saved properly, we can check, we can query our embeddings, and for that purpose we can write a query like this, that what question we can ask. Let's get inside a book, and let's ask something from this book, shoe dog. So if I get inside this shoe dog, this is the book, so we can ask some question from here. So what question can we ask? Let's come down. Let's see if we here something with Johnson owned the East Coast Park, taking over his store. So Bob Odell, I know the name, of course. Everyone in Oregon know the name Odell. Odell had been a standout of Bauman's 1965 team, not quite a star but a gritty and inspiring competitor. So something like this, it is written here. So we can ask a question, that is, who is Odell? We can ask this question. Let's come back to the query and let's ask this question, that who is Odell? So we'll be asking this question to Llama 2. So now how we can represent this query? So we can name it as query similar, as we'll be doing a similarity search among the vector embeddings. So call the text embedding and we'll be doing a similarity search now. So we'll be calling this similarity search method, and here inside we need to put our query then as the parameter. So query. So the similarity search method will go through all the embeddings that are saved inside the pinecone database, and it will try to find out something similar that can answer this question, that is, who is Odell. And here you can define the k nearest neighbor. That means how many documents you want. Let's say I want 4 documents. That means this similarity search method will try to find 4 similar chunks that can answer this question, who is Odell. So let's run this piece of code. Then we need to write this query similar, otherwise it will not come. Let's run this piece of code. Okay, here you can see we have got 4 document pages. Here is the first one, and then the second page document, and here you can see the third page, and here this is the 4th page. So we have asked for 4 text chunks that are closely related with the query embeddings. That's why we have got this sorts of answer. Would always have the big belly laugh about. This would always have the big belly laugh about something. So you can see here we have /t. So these new line characters and /t is causing the problem for us. So we need to redefine, we need to remove these new line characters to get a clear answers. We'll be doing this thing, but for now at least you can see that our query embedding is working. So if we query any question to pinecone, then we'll be able to get the answer. But we'll not be querying the pinecone database in this way. We'll be using the Llama 2 to get the answer more precisely, and we'll be doing this thing next. now to query the embeddings, we need to call the Llama 2. So we can call the Llama 2 from the Together AI class that we have already created. So here you can see this class together.py. So from here I can call the whole things, because I don't need to repeat the same things again and again, and for that I can just copy up to this system prompt, and we can call it up to this default system prompt. We can call this up to this default system prompt and get prompt instruction, and we can call it up to the default system prompt. So let's say copy this thing, and you can come back to the, and you can come back here and just paste it. So our Together AI class is now imported. You can see we need to import the Together, and then here is the Together API key I require. So we are calling the Together API key, and our model is, we are initiating this Llama 2 70B chat model, and here also we are doing this. Here also you can see I have defined the Together LLM as Together LLM model is Together Computer Llama 2 70B chat, and the temperature is 0.1, maximum tokens 1024. And here in here Together API key, self Together API key. And in here you can see this beginning of the instruction and the end of the instruction is written. So default system prompt is here. This is the default system prompt, that you are helpful, respectful. This is the default system prompt, that you are a helpful, respectful and honest assistant. So we have read this thing several times, we don't need to repeat the things again, I think. And so in here we are keeping the system prompt the same. We are not changing the system prompt here, but we are changing the instruction. Our instruction will consist of the context and the question. So we'll be asking the question there, and the context will be defined. Now we are passing the system prompt and the instruction inside the get prompt function. So let's run this piece of code to see how it looks. Okay, so you are a helpful, respectful and honest assistant. Always answer as helpfully as possible using the context text provided. Blah blah blah. So this is okay. Our instruction is all inside the instruction tag and the system prompt. Where is the system prompt? Yes, this is the system prompt. So okay, and in here you can see this from LangChain prompts import prompt template. We are calling the prompt template here, and we have created our own templates, that is my template, and this will take the, and we are calling the get prompt functions to take the instruction and system prompt as the parameter. So this get prompt function will take, and so this thing has been done here already. So we are just giving it a name, that is my template, and here we are creating another variable that is called Llama prompt. So this will call the prompt template method, and it will take the main template that we have created, that is my template. So template equal my template, and the input variables are context and the question. So we will be passing the context and the question as an input, as the input variables. So here now is the main thing. We need to create a question answering system using LangChain. And for that purpose, the first thing that we need to import is from the LangChain schema, we need to import the prompt. And this is the QA chain, that means question answer chain, that we are creating. We have imported this retrieval QA class before from the LangChain schema. If you can remember, this class allows creating pipelines for question answering using retrievers and LLMs. The retrieval QA is constructed by using LLM, chain type, retriever, chain type, keyword arguments, and then source documents, return source documents. So Here as our LLM, we are using this tog LLM, that means together LLM. Here you can see we are using this LLM, so we can copy this and we can bring it back here, just paste. So our LLM is the together LLM, tog LLM, and we are using this chain type, that is staff. And chain type is set to staff, which is a predefined pipeline that does text retrieval followed by asking the LLM to answer based on the retrieval documents. Staff chain type will mainly ask the question to the LLM to answer based on the retrieved documents. And the next parameter is retriever, that means from where we will retrieve the information. We are retrieving the information from the text embedding. That's why I am calling the text embedding, and from the text embedding there is a method that is called as retriever. I am calling as retriever method to retrieve the information from the embeddings. And this search keyword arguments variable is basically a dictionary, and it defines the k nearest neighbor equal 5. That means we want 5. We want to retrieve 5 documents or 5 pieces of chunks. So that is the thing. And then this chain type keyword arguments, that is the additional keyword arguments to pass to the staff chain stuff. So it is basically used to customize. This allows passing additional keyword arguments to customize the selected chain type. In our case, we have selected this staff chain type, so you can customize this thing by using the chain type keyword arguments. Chain type keyword arguments can be used to configure the reading comprehension model used by passing arguments like model name, model keyword arguments. Basically, this chain type keyword argument allows customizing the specific pipeline steps used for the selected chain type. The keyword arguments accepted depend on the particular chain type's implementation. See, so here we will bring some customizations. So let's do one thing. Let's copy this and let's bring some customization here. I can create another variables, and here we can create a dictionary. And inside this dictionary, the key should be the prompt, and we can use our own prompt as the value. That means Llama prompt. So let's copy this Llama prompt as the value and paste it. So here this is our chain type keyword arguments. So we have customized our chain types. Now our chain types will take the Llama prompt template. So now we are getting so many new line characters or /t or /n in our text. You may remember the last text that we ran through. Here you can see we are unable to read the text because of the /t and new line characters. So that's why we need to clean up the text a little bit, and for that purpose we are writing another function here. You can see this is for that we are importing text rep, and we are creating another function here, that is rep text reserve new lines, and we'll take the text as parameter and width should be 110. We're splitting the input text into lines based on new line characters, and then we are joining the rep lines back together using new line characters. So here you can see rep text joining the new line characters back together using new line characters. So then we are returning the rep text. So this is a simple function, just removing the new line text and wrapping the text nicely, and then we're creating another function, that is process LLM response. It will process the response. Whenever we'll be getting any response from the large language model, then it will do, and then what it will do, it will not print the LLM response directly. It will wrap the text first and remove the new line characters, and then it will print the result only, so that it looks presentable. So these two functions will be introduced here. So let's run this piece of code. Now our chain and almost everything is ready. Llama 2 is ready. So what can we do now? We can write this piece of code. We can go for a query, that the query that we have asked before, that is who is Woodwell. This question will be asking again. We'll be asking this question again, and let's see if we can get a good result here. And here we have defined the LLM response that we have just introduced there. This LLM response variable is nothing. This will run the question answer chain, and it will take the query parameter. So what is the query? That is, who is Udwell. So let's call the process LLM response function. Let's see what. So now we have got the correct answer. That is, Udall is a friend of the narrator's who is a paraplegic. He is a former track star who was injured in a car accident and is now confined to a wheelchair. So despite his disability, Udall is a positive and energetic person who is passionate about his work and enjoys spending time with the narrator and their mutual friends. So now you can see it looks nicer than before, and there is no new line characters or special taglines involved here. So it looks nicer, but we don't know that from which book they have collected this answer. So let's go for another query. Just copy this thing and paste and ask that. Let's ask this question: that in which book the author discussed about Udwell. So let's run this piece of code. So here you can see the author discussed Udwell in the book Shoe Dog by Phil Knight. So it is correct here in answering his question, because if you come back here, this book is the book we were reading is Shoe Dog, and here here the author was talking about Bob Udall, and this is the book, that is Shoe Dog, and it was written by Phil Knight. So the answer is correct. So you can see from the huge text chunks, it is finding the answer pretty quickly. Only with 3.25 seconds, it was able to find the answer. Let's go for a comparison among the books, and for that you can see I'm asking this question: that whose writing style and narrative voice did you find the most compelling, and who structured their book in the most engaging way? So now I'm asking the Llama 2 to go for a comparison among the four books and try to find out whose writing style and narrative voice did you find the most compelling. So let's try it out. So here Llama 2 have come up with an answer within 16.0 seconds. That means within 16 seconds he was able to find the answer. So I think in the meantime he has studied the four books, so it's pretty quick. Based on the provided context, it seems that Malcolm Gladwell's writing style and narrative voice have been widely praised for their engaging and thought-provoking qualities. So many of the reviewers mentioned that Gladwell's use of anecdotes and interviews to illustrate his theories on human potential and success is particularly effective in capturing the reader's attention and making complex ideas more accessible. In terms of structuring the book in the most engaging way, it's worth noting that Gladwell's books, including Outliers, are often praised for their clear and direct prose, which makes the reading experience both enjoyable and thought-provoking. The book's structure, which whips together anecdotes, interviews, and scientific research, has been described as masterful and impeccable. Therefore, based on the provided context, it seems that Malcolm Gladwell's writing style and narrative voice are the most compelling, and his book Outliers is structured in the most engaging way. So you can see that he has marked the Malcolm Gladwell's Outliers as the most engaging and compelling, so among the four. And he has reached to the answer within 16 seconds. So that means in the meantime he has read all the books and he has come up with the best books, that is Outliers, in case of compelling and engaging stories. I'm asking another question that is pretty interesting: that what anecdotes among the four books reveal the most intriguing habits or mindsets of great leaders, which were most reflective of their leadership qualities? So let's run this piece of code now. So here you can see again he is coming back with the Malcolm Gladwell's book, that is the anecdotes in Malcolm Gladwell's book revealing intriguing habits and mindsets of great leaders. In Outliers, the story of the Beatles' rise to fame highlights the importance of dedication and practice in achieving success. The anecdote about the Beatles' performance at the Cavern Club, where they honed their craft and developed their unique sound, demonstrates the power of deliberate practice in achieving mastery. This anecdote reflects the leadership quality of persistence and commitment to excellence. So here he has written so many things, but all the things are regarding to outliers. So it is already understandable that Llama 2 liked the Malcolm Gladwell's books pretty much. That's why whenever we are going for any comparison, he's picking it up every time. Now if you want, you can change the model in Together LLM. You can use this 13B or 15B model. Then you can ask several questions to the Together LLM. So you can see we are using 70B chat. Then here I have used a different model that is 13B, and I have asked the same question, that who is Udwell, and we got a different response here. Based on the context, Udall is a former track star who is now a wheelchair-bound man and a friend of the narrator. He is described as being very different from the narrator, but they share a similar approach to work and have a deep desire to win. Udall is also described as being a man of good spirits despite his injury, and is a source of inspiration and support for the narrator. Here you can see the difference between the answers. Here the 70B model answered that Udall is a friend of the narrator's who is a paraplegic, who is a former track star who was injured in a car accident and is now confined to a wheelchair. So the answers are quite different. You can try with 70B, 30B or 7B models to get different kinds of answers. Welcome to the new project. This project is about a payroll audit system. So get familiar with the project scenario. We are creating a payroll audit system for the employees that will check anomalies with Llama 2. The automated system will go through different records to find anomalies in the salary sheet of the employees. It can track the daily overtime data of the employees and can find if any fraudulent entry or dissimilarity to prevent extra salary paid to the employees. So I can show the things practically. Here you can see one table is there, and there are several columns. The first column is for the date. You can see 6 September 2023, 7 September 2023, and 8 September 2023. So the data going on like this. And then the employee ID, this 1500 is an employee ID of a single person. And then we have the working days of the week, that is Monday, Tuesday, Wednesday, Thursday, Friday. And on each day, an employee can maximum do overtime for 6 hours. He cannot do more than that. In any day, it can be 6, 5, or 3, 4, something like this, but he cannot do more than 6 hours in a day. And after doing the overtime, employee will input this amount of hours he did the overtime as an input in an Excel file or in a other source of receipt or somewhere else. So what happens if an employee inputs more than 6 hours a day? Sometimes they may input 7 hours or 8 hours intentionally, just to get more money. But to prevent this sort of culture, or to prevent this sort of system, we can check the data through Llama 2, and we can ask Llama 2 to find if there is any anomaly. So we can ask Llama 2 to suspect if there are any kinds of anomaly in the data, and Llama 2 is very good in finding these sorts of dissimilarity or fraudulent data type. So it can be used anywhere. You can input the receipts of the employee. You can upload the PDF files, Excel files, or CSV file, and Llama 2 can go through these and just verify the data. Okay, there are some dissimilarity in the data, or this data is or I suspect there is something wrong in the data, you need to check it again. Every day there are so many transactions are going on, so it's not possible to check everything manually. So we'll be building up a system that will go through all this data and it will check if there is something suspected. So we'll not be using Excel file or CSV file or PDF file here. Already you know how to manipulate these PDF or Excel files, so you can do it easily. And in this time I will be creating this source of data by using the polars table or pandas data frame. You can use the polars or pandas data frame to create this source of data. So this whole thing will be a demo system, so it may look ordinary, but you can apply this thing, but you can improvise on this system to apply this thing on your daily day-to-day life or in any official work purpose. So let's jump into this and check what can we do. So the first thing that you need to install is pip install polars. If you have the polars installed already, then you can upgrade it, and you can do the same thing by using the pip install pandas also. If you are not familiar with the polars, then I would say that you can use the pandas data frame, no problem, the same thing. But polars are normally used to work with huge data or huge data sets. You'll get fast response whenever you will be working with polars data frame with huge data set problems. So let's meet with polars here. If you get inside the polars, then you will be able to see here that welcome to fast data wrangling. Polars is a lightning fast data frame library or in-memory query engine. Its embarrassingly parallel execution, cache efficient algorithms, and expressive API makes it perfect for efficient data wrangling, data pipelines, and snappy APIs, and so much more. So for the purpose of data wrangling and data pipelines, this is a useful case. And in the language, you can use the polars or Rust and Python. So we are doing the program, so we'll be using the Python, and we'll be experimenting the polars data frame today. So first we need to create some data that we'll be playing with, and we need to work with date and time, and for that purpose we are importing this from date time, import date time and time delta, and we are importing polars as PL. So first in here we are creating a data frame for the overtime. We need multiple transaction for different employees, but here we are creating a transaction for a single employee ID, that is employee ID 1000. You can see here. So let's come from the first. So here we are creating a polars data frame. You can see pl.data frame, and then what it takes, this data frame takes a Python dictionary. You can see from here to here, this is a Python dictionary. Here this key pair of the dictionary are the columns, and these are the values. So here you can see the first column is date, then comes the employee ID, then the weekdays that you will be working. These are the 7 columns you need to create your data frame. And inside the date we can create any date range from which date you want your data. I want the data from 1/1/2023, that means 1st January 2023, and we basically generates a date range from 1st January 2023 to 10th September 2023, and the interval would be in a daily interval. Date range method takes the few parameters. The first parameter is the date time, that is from which date you want your data. I need the data from January 1st, 2023. So you need to write the code like this. You need to write the code in year, month, and day format, and then up to which date you want your data. So I want my data up to 10th September 2023, and here the time delta, that means the time interval. We want to go with a daily interval, that's why we are keeping the days equal want. So that means we want every day's data. Then so we are using the millisecond at the time unit. This timestamp MS converts the timestamps to milliseconds, and then we're keeping the eager equal true. That this eager equal true loads the data into memory immediately instead of lazily, so it will not take time. Whenever you'll be working with this, the data will be loaded instantly. And here we are creating an employee ID. First, we are not going for the dynamic ID. We are not going for the dynamic IDs here. We are just keeping a static ID, that is 1000. So first we'll create the overtime records for one ID, then gradually we'll go for multiple transactions with different IDs. So this is the overtime hours for each day. That means the employee and that means the employee ID 1000 is every day doing 6 hours overtime. So now if I run this code, then the whole thing will be clear. I think it's a long one, and this date here you can see the columns are created: date, employee ID, Monday, Tuesday, Wednesday, Thursday and Friday. And then here is the date times, and this is the millisecond, so whenever the transaction took place. Currently it is 0. So we don't need to deal with this because we will not be changing this thing. We are keeping it as same. The timings are always this. And here you can see the data started from 1st January 2023 and it has stopped at 10th September 2023. The next thing is employee ID and the working hours each day. So we are keeping this working hours as 6. So our first data frame for an individual employee is okay. Now it's time to create multiple employee IDs, and this code generates test overtime data for multiple employees. First, we are creating a loop that is for I in range 1001 to 1501. So that means we are working with 500 employees. Okay. That's why you can, if you want, you can increase your employee size. If your CPU is powerful, then you can increase your employee size to 2,000, 3,000, or maybe more than that. And we're keeping the step as 1 because we want every employee ID, every employee's ID. And so there will be total 500 employee ID. Starts from 1001 to and it will finish with 1500. Now we want our for loop to loop through all the IDs. That means 1001 to 1500, and we want it to create a new data frame that is called overtime temp, and it will create the data for each employee ID similar to this data. So, and as we will be using the same data for every employee, that means this data will remain same, only we will change the employee ID. That's why I'm copying the whole thing from here, that is pl.data frame, and that is Polar's data frame. I'm copying the whole data frame from here, and I'm just pasting the data frame here. You can see this is the same data that we have just created before some time. So all the things will remain same. That means the date, the data range, and the timings. It should start from January 1st 2023 and it will end on 10th September 2023. And then time delta is okay, time unit ms eager equal true. But the only change I'll bring here, that is the employee ID. It was static before, but now it will be dynamic, that I want to keep the I. That means for I in range 1001 to 1500 you create the ID. So whenever the for loop starts looping through, that time it will create new employee IDs. It will create this 500 employee ID, and it will create the same source of data that we have created for one employee ID. So these are the whole things. Then we will concatenate all this data inside our previous data frame, and the name of this data frame is data frame overtime. So here you can see we are calling the polars to concatenate the data. That means this was the previous data, that df overtime, and we are just concatenating this overtime temporary data that we have just created from here, and we are adding this data into the previous data frame. So now our data frame will be enriched with multiple IDs, and now there will be so many transaction data. And then at the last point we are using this how vertical. That means how will you concatenate the data, and this time we'll be using the vertical concatenation, and the vertical concatenation stacks the data frames on top of each other to build up the full set of employee records. So our employee records will be stacked vertically. And let's start on this piece of code. Okay, it's ready. Now if I want to see my data frame now let's check the data frame head. That means we want few lines from the top. Oh no, it should not be inside the for loop. I need to keep it here. And now run the code. Here you can see this is the data that we have created, 1066. So it's not understandable that if any change occurs from here, because this is the first few lines of the data frame. So we want the last lines. So for that we can just type here that df.ef overtime dot tail. We can call the tail to check, and if I remove the data from here and if I run this code, now here's the tail. You can see the last ID, that is last employee ID, that is 1500. So we have the employee ID up to 1500, and then you can see this is the last date, that is 10th September 2023. So we have created multiple IDs for, so we have created multiple IDs now, and we have the same data for every ID. That means every employee has 6 hours overtime under his belt each day. So now this is okay. So how many rows are there? If I want to check, then we can check it by df overtime data frame, and we could call this shape method. This shape is another method that we can use to check the shape of the whole data frame. That means how many rows are there, how many rows are created. So let's remove these and let's run this piece of code. So here you can see there are 632753 rows are there in total. So it's a huge data set. Now we want to create some statistics for or the basic summary from the data frame that we have created. Let's say we want to collect the minimum overtime, maximum overtime, and the mean, that means the average of each day's overtime. So we want to collect this data. We want to show this thing from a statistical viewpoint. For this purpose we are writing this code. The first is first it defines a list of the day column names. That means the work days, that is Monday, Tuesday, Wednesday, Thursday, and Friday. Then we want the average, minimum, maximum, and total hours per week in dataset. So we are creating another data frame here, that is overtime stats. This will call the describe method from the overtime data frame to generate a summary statistics for each of the columns. Though we'll play with the numbers only, that's why we don't need any text format data, otherwise it will not work. So that's why we are deducting 2 columns from there. We are excluding 2 columns from there, that is date and the employee ID. We don't want the date and employee ID here. This is not required. That's why we are using this exclude method. First we are calling the polars data frame. From the polars data frame we are calling all the columns, you can see, and from the columns we are excluding these 2 columns, that is date and employee ID. So this exclude method will take these 2 parameters, and after excluding these 2 columns we will have 5 columns left, that is the day columns, that is Monday, Tuesday, Wednesday, Thursday, and Friday. And we are filtering this thing, and for every day we want this mean or average and the maximum and minimum working hours, minimum overtime hours recorded. And then whenever it's done we want to create another column. That's why we are calling this select method. Then in here we are creating another column. For that we are using this alias method, and the column name is total. So this column will be added with the day columns, that means this column. So on top you will see these 5 columns and another column. This is the 6th column. In total you will see 6 columns there, and there will be other rows like minimum, maximum, and there will be 3 rows, that is minimum, maximum, and mean rows. So the whole thing results in a data frame with the min, max, and minimum values for each day column, plus a total column with the sum of hours per week. So mainly it calculates a basic statistical summary, that means with min, max, and minimum and total for the overtime hours columns, and at the same time it is excluding any non-numeric columns. And this polars transformation allows us to easily filter and shape the described output. Better check this thing. So I am writing this df overtime stats.head. So let's check the first few rows of the overtime steps. overtime states, that so that it will be clear to us. So here you can see we have created another new column, that is total, and we're going for mean, minimum, and a maximum. And every day's mean, minimum, and maximum remains same, and the total for each week is 30 hours overtime. This is the mean, and the minimum is also the 30 hours overtime, because every day they are doing the same thing, so that's why the minimum and maximum is same, but it will differ whenever we'll change the data, or whenever we'll produce some fake data. At that time you will be able to see the difference. I want to get the single employee stats now, so for that purpose we are creating another data frame here, and this data frame will just filter the result from the overtime data frame. So we are using this filter. The first thing is that we are calling the employee ID columns from the polars data frame, and this employee ID should match with 1001. That means we want the information only for this 1001 employee ID, and then and after getting the 1001 employee IDs data, we want to go for another filter, that is again we are calling the polars data frame, and we want the date columns, and the date column must match with the 10/9/2023 date. So that means we are calling for the 10th September 2023 date and data of the employee ID 1001. So let's see what the data comes. So just copy this, Control C and Control V. So here you can see the output, that is shape one, the data for 10th September 2023, and employee ID is 1001, and on each day he has worked 6 hours overtime. So this data frame has met the two conditions. The first condition is we want the employee data for 1001, and yes, he is coming with the data for 1001, and we want the data for 10th September 2023, so it is also coming for 10th September 2023. So why we need the data of 10th September? Now what will we do with this data of 10th September 2023? Now we have the data up to 10th September 2023, then we'll try to exploit some new data. We'll try to input some new fake data, and we'll change the value of this from 11th September just to see if the change occurs. Now we will input some fraudulent data, or we'll do some intentional mistake here. We'll try to change these figures from 6 to other we'll try to change the overtime hours from 6 to any other things, and we'll see what happens. Now let's assume that today's overtime sheet is submitted by all employees, and some of the employee accidentally booked 8 hours in a day. So here it is happening. So on the Monday, we have someone has did this intentionally, that the input is 8 hours. Now the data frames will not keep in the same conditions. Now again we are calling the for loop to insert that data. So we are doing all the things as before. We are copying this overtime template, and then we are concatenating the whole data to the overtime data frame. The same thing we are doing that we did before. Now in here we are inputting some new data. When we are inputting the data for the 11th September and the 12th September. If you can remember, we did it before in the same way. So we are also calling the data range. We are calling the data range method from the polars, and we are selecting the date time from 11th September to 12th September, and time delta and the interval will remain same. And the only change that we brought here is the input. Somebody intentionally did this mistake, that he did 8 hours overtime on Monday. After doing the overtime template, again we are concatenating this template with the overtime data frame, and we are keeping it vertical stack. We are keeping it as a vertical stack. So all the things are same. Now let's run this piece of code, and so I want to check the number of rows here. Now the number of rows currently is 12,753. So before sometimes we have checked the latest stats by employee. So again we want to check the latest stats by employee. Now it will be changed. So I want to check the status of the employee for the 11th September 2023, and I want to check I want it for the employee ID 1001, just to check if our input is okay. So let's run this piece of code, and here you can see again, and here you can see this is the employee ID 1001 on 10th September. If you can remember it, the input for Monday was 6 hours, but here now it has changed. For the 11th September, the input is now 8 hours on Monday. So that means the employee ID 1001 did 8 hours overtime on the Monday. Now there are some change took place. Let's check if Llama 2 can catch this anomaly. So for that purpose, the first thing that we need is to call the Llama 2 config. The first thing that we need is to call our class, and from the together AI class we are calling the Llama 2, as you know how to handle this thing by the time. So again, all the things are remaining same. We are calling the together API key, and then we are initiating the model, that is Llama 270B chat model, and the together LLM class is ready, and it will reply us with an output that will be the text, and the maximum tokens you can increase here. We can keep the maximum token as 1024, temperature we are keeping as 0.7, and the together API key is okay, ready. So almost all the things are okay. So here also together LLM, we are keeping the maximum tokens as 1024. So here is our instruction. This is the beginning of our instruction, and this is the end of our instruction. So beginning of the system, end of the system. So now our default system prompt is that you are a helpful, respectful, and honest assistant. Always answer as helpfully as possible. The same thing that we were doing for the last few projects. And then we have the function, that is definition get prompt function. So all the things are ready now. So just write this piece, just run this piece of code. Now here we need to declare the get prompt function, and this get prompt function will take the instruction and new system prompt equal default prompt. You can see. So we have worked. So the things are remaining same. System prompt is beginning with the begin system prompt and end system prompt, and then prompt template is also remaining same. It will be inside the begin instruction and the end instruction. So all the things are ready now. So the main thing is that now we are randomly picking one employee ID, and we want to check his data. Let's say we want to check a wrong data, and that is for the 11th September, that is for the date of 11th September 2023, and we want to check the data for 1001 employee ID. So we know at that date he did some mistake. He input his data was manipulated with 8 hours of overtime on Monday. So you can call any data. So we are calling this employee ID from the overtime data frame. So you can call any ID if you want, just by filtering this thing. So you need to input the employee ID here, 1001 or 1005. Any employee ID you want to input, you can input here, and then the date time for which date you want to check the data, you can check the data here. And we are keeping the whole things inside a variable that is called out. So now our main prompt will be there. So we can write the instruction here, but we are not writing it as the instruction to keep the simplicity. So we are keeping it as text. So this is the text that the LLM chain will take as the input. So what is the input? That is there any anomaly in the data? Respond in a word. And average employee working hours are. So it don't need to respond in a word, just we want the explanation, so we can keep it like this, that text. So here you can see, is there any anomaly in the data? Average employee working hours are string data frame overtime stats that item 0 to 6. We're calling this overtime stats data frame, and we are calling the item number 06. That means row 0 and index, and the item index is 06. That means we are calling this. This is the overtime stats, and we are calling this 06. That means That means we are calling the mean row and we want the total hours. That means 30 hours. So this will be the total hours. So we are calling this value here just by using this method, method. So overtime stats. That means average employee working hours are 30 hours. So whatever the hours he will get in the overtime stats, so he will use this as a dynamic format here. So but at current it is 30 hours per week. So to clarify this thing, we can call this data frame that is out. So let's call this data frame to check. So let's check this data frame that is out dot head. Let's check the data frame here. Let's run this. Nothing is coming here, so we can run this in here. Control V. Let's check the data frame. And here you can see this is the data frame, that 1001. So this is the 1001 employee ID on the 11th September. His overtime hours are mentioned here. Here what has been written, that this week I charged total string out dot item 02. So the 02 should be 0 is this one and 0 1 2. So this is the first thing. So that means it is calling this number, that's 8 hours, and then it is and then again it is calling 03. 03 is this one, this index, so 86. 04 is 6, this one. So that means actually it is adding all the hours, all the overtime hours, and calculating the total overtime hours here. So this week I charged total second, third, fourth, and fifth, sixth row, all the rows it is adding, and then it is calculating the total hours here dynamically, nothing else. I've just brought the thing down just to make it clear for understanding that okay, so this is the ID that we are checking, that, and we are checking that okay, for this ID the data are correct or not. So in here the first thing is that, is there any anomaly in the data? So average employee overtime hours are data frame overtime stats item 0 to 6. That means 30 hours we have already seen. And now this week I charge total, how much I charge. So this is this information we are taking from the output of the item 02, item 03, item 04. We are adding all the things from the output. So that means we are adding all the things. Item 02 is item 02 index is this one, and then we're adding this one, this one, this one. So we're adding all the overtime hours of each working day, and then we're getting a total amount, and then we are calculating the total amount here. So that means this week I charge total how many hours? That will be the sum of this that will be the sum of these numbers. And then here I am saying that I overtimed this, I overtime this. Now we are making this string format of the output. I overtime these hours per day from Monday to Friday. So again individually we are writing that how many hours I overtime every day. That is also I'm writing on my text. So that means in this week I worked 8,666 hours. So that is the final thing. Now let's run this piece of code. You may not understand this thing clearly. It is looking a little bit clumsy, but whenever the result will come, you will be able to understand the whole things very clearly. Now let's bring Llama 2 into play. So for that I need to write the system prompt here, and the system prompt is, you are an advanced assistant who is very good at logical thinking and mathematical explanation. So we need a mathematical expert to solve this puzzle. And then the instruction is, answer the question logically that is asked in the text. So already I have asked a question, that is there any anomaly in the data. So this is the question remains on the text. So I'm inputting the text here, and then we are creating the template, and for that purpose we have already called the LangChain prompt template. Now we are creating the template, and we are using the get prompt function, and this get prompt function is taking the instruction and system prompt again. And if I want to print the template, let's keep it as like this. Just check the template here. Yes, my template is well inside the instruction and the system tag. Every time you need to make sure this thing. Now you can run the codes, and now the prompt. Now from the LangChain prompt template, I am calling the prompt template, and our template is this one. Our template is this one with the system prompt and the instruction, and our input variables is text. This is the text that we are choosing as the input variables, and then the LLM chain. We must call the LLM chain to run the prompt, and again from the LangChain we are calling the LLM chain, and the prompt will remain the same. And we are inserting the prompt template as the prompt, and LLM again we are using I am using the tog LLM, that means together LLM. And the output, now let's create the output. LLM chain dot run the text, and we are requesting the LLM chain to print the output. Now let's run the code. It is taking a bit of time, it will take. So now the answer is here. So you can see the answer, and this was our instruction and system prompt. You are an advanced assistant who is very good, and then answer the question logically. Now what is the answer that we are waiting for? That the average employee overtime hours are 30 hours per week, but this week 32 overtime hours were charged. So this is an increase of 2 hours from the average, so which could be considered an anomaly. So furthermore, the overtime hours per day from Monday to Friday are not consistent. The hours per day are 8666 hours, which adds up to 32 hours, exceeding the average weekly overtime hours. It is unlikely that an employee would work the same number of overtime hours every day, which could indicate an error in recording or reporting the data. So therefore, it's reasonable to conclude that there is an anomaly in the data, and further investigation is necessary to determine the cause and correct any errors. So you can see how the Llama 2 answers this question so correctly. And one thing to mention, that I didn't say to Llama 2, I didn't say to Llama 2 or that the maximum working hour is 6 hours. I didn't say it anywhere. So but from his own experience he understood that okay, so 6 hours must be the standard. So one day an employee did 8 hours of work, so that means one day an employee did 8 hours of overtime, so that means there are some anomaly in this data. So you need to recheck the data again and confirm if it is fraudulent or if it has been done mistakenly. So this is a nice way of checking. So this is a nice way of checking the data. And again in here you can see it's unlikely that an employee would work the same number of overtime hours every day. So this is also unlikely. So he has understood that we have created a fake source of data, and we did it intentionally. We inserted that every day they have worked for 6 hours overtime. So this is also a kind of anomaly. So this is a common sense. So Llama 2 has used some sorts of common sense also to derive to this equation, that the reporting or the recording of the data may have some error, because it is so much continuous and frequent that you cannot expect this sorts of overtime data from an employee. So this was a demo system, that's why you may seem it is not so effective, but by using your own creativity you can create these sorts of system that can be helpful in your day-to-day life. And Llama 2 is there for you to solve, and Llama 2 is there for you to take the maximum workload. So why don't you try to create your own?